Part 3. Applying Critical Thinking in Practice. In this part, getting to the heart of the matter, cultivating critical writing skills, learning to speak and listen critically. Chapter 9. Getting to the heart of the reading matter. In this chapter, identifying initial clues from texts, extracting the deeper golden nuggets, using time-saving techniques. Critical thinking is fed and nurtured by great books, which firmly places critical reading skills at the heart of good learning. Critical readers do not accept passively what they read. They read actively, constantly weighing up the strengths and weaknesses of the author's case. As I explain in this chapter, they move beyond meekly bowing down before presented facts and instead question and assess all the evidence, whether it's stated openly or submerged deeply within. Of course, critical reading is about discovering ideas and information, but that's no use if you can't remember much of what you've read afterward, or if you have trouble getting your hands on the specific bits you need when you're short of time. So, to close this chapter and put the seal on your critical reading skills, I offer some practical tips on note-taking and skim reading. Appreciating critical reading as a practical skill. In some contexts, being a passive and basically uncritical reader is sufficient. In fact, most education encourages this approach. The main skill that schools develop is the ability to summarize. The ability to select is marginalized, and challenging or disputing sources, whether these are other books or teachers, is actively discouraged. Colleges are no better. This may be because education operates in a bit of a sealed bubble. The exam board or other educational administrators tell the teacher what to teach. The teacher tells the students what to learn, and the whole system justifies itself when the exam process checks how much children remember. Critical thinking doesn't come into it. Put another way, a course can be badly designed, out of date, and irrelevant, but if the people who teach and market are happy with it, that's the course you have to pass. Tip. This focus may lead you to think that critical reading isn't a necessity. Maybe it will even slow up learning those facts. But don't make this mistake. Instead, look on it as an investment for later in life. Take healthcare, for example. Professionals of all kinds are responsible directly to their clients, and reading that a particular new approach is effective isn't enough if people using it find that it makes the situation worse. Doctors are deluged with medical studies that argue persuasively for new treatments, which some years later turn out to be ineffectual or even harmful. A careful critical reading of the claims made for the treatment may reveal early on that the evidence advanced for them is weak. So having critical reading skills can be a matter of life or death. Reading between the lines. Wouldn't life be much easier if you could assume that what you read is a straightforward account, and that by and large authors are truthful? Yet people can be wrong, and texts can be misleading. And for many more reasons than authors simply being mendacious. I swear it's true, honest. They may be misinformed, out of date, simply incompetent, or mixed up, muddled, or just lazy, or all of these. So you need to be a skeptical reader. In this section, I describe a number of mental checks to run on any piece of writing that you're reading critically to help assess the soundness of its content. You may be surprised just how much information you can glean from a few fairly basic quality controls. Checking the publisher's standing. Tip. If an article or book is from an academic journal or an academic publishing house, you can assume that several people with relevant knowledge of the themes and topics it covers have checked it. They should have knocked out sloppy writing full of basic errors. Plus, you can be sure that if it's from a respectable source, you can quote safely from it without risking looking silly. Yet, despite what even some critical thinking experts say, all topics in scholarly life involve a range of diametrically opposed opinions. Therefore, this academic type of check is far from a guarantee that the text isn't making more sophisticated and significant mistakes, that it isn't partisan, or indeed that the work's whole approach isn't wrong. Remember, academics tend to hunt in packs, and so authors and reviewers can easily find experts to back up, or deny, adopted positions. The influential philosopher of science Thomas Kuhn says academics are creatures of fashion who divide themselves into tribes. Yet real life features plenty of examples of dominant theories being wrong and minority views being right. And, last time I looked, academics are part of this real world. Check out the box "Sometimes Everyone is Wrong" later in the chapter for some examples of this. Cross-examining the author. Tip: ask yourself whether what you're reading is an academic study, a news report, an expert's opinion, or an anonymous website. If one or more authors are named, what's their backgrounds, their areas of expertise and experience? In other words, consider what qualifications they have to write on the subject. Being aware of potential author bias. Critical thinking professor Richard Northedge, when writing advice for students on sources, praises an article by an academic named Richard Layard on social inequality. He counts in favor of the article the fact that Professor Layard is an advisor to the UK government and had been, as it were, commended for his services by being made a lord. To me, though, this fact indicates that Professor Layard's views could be, I'm not saying they are, just that they could be, influenced by what's politically desirable or useful to say, as well as by what's academically important to say. Richard Layard is at the top of the social pyramid in the UK, very much part of the establishment, and his perspective on the British government's efforts to help disadvantaged folk might seem to be a little too cozy. Perhaps you've asked yourself what qualifications I have to write about critical thinking. You should have. Well, to put your mind at rest, I do have relevant degrees, and I researched and co-authored a report on the subject for the UK government. For Dummies books also require a popular touch, and so it's relevant that I've written many books for general readers, too. Authors, having first-hand relevant experience, makes their books more credible. But look out for authors whose experience may indicate that they have a bias. It's an easy mistake to make. For a possible example, see the nearby sidebar, Being Aware of Potential Author Bias. Considering why the text was written. Tip: ask yourself whether the writing is supposed to serve a particular purpose, perhaps to record an event, or whether it's intended to find a large paying audience and make the author money, or maybe to obtain a qualification. Remember, publishers need to sell books, and even academic writing is a product of fashion. Authors are more likely to write such texts if they're part of a live debate going on within the field. A live debate may be one with recent discoveries and developments, or where a lot of money is being spent on new research. In all such cases, try to put the book into a wider social and scientific context. Appraising how a text is written and presented. Consider whether the text is presented as a factual report or as a logical argument. Or is it part of a campaign, even a piece of propaganda or advertising. If it's a piece of research, how well has it been done? Judging this last point is by no means straightforward. Evaluating research is a special process involving consideration of several factors, as I describe in the nearby box, checking the methodology. Even so, a critical reader should at least consider this issue. Checking the methodology. When authors write books, conduct studies, or investigate a topic, they operate within a research paradigm, a theoretical framework that affects how they view and investigate the subject. In formal academic studies, authors discuss the research paradigm up front, and so that's straightforward. But more often, they leave the nature of the chosen paradigm in the background, as a given. So the critical reader has to make a specific effort to work it out and consider how the choice may skew the information reported. Here are some useful questions to ask when looking at reports and research findings in the broad area of social science. Theoretical or empirical? Is the text primarily concerned with ideas and theories, or primarily based on observations and measurements? Most texts mix the two approaches, but critical readers need to identify which element should be the primary focus, even if the author seems confused. Nomothetic or ideographic? These grand terms originate from ancient Greek. Nomos means law, and idios means own or private, and refer to laws or rules that apply in general in contrast to ones that relate to individuals. Most social research is concerned with the nomothetic, the general case, because even when studying individuals, researchers usually hope to generalize the findings to everyone else. Always bear in mind the extent to which entirely valid observations about a particular case can safely be generalized. Cause or correlation. So many people mix up these terms that the error has its own special name. Cum hoc ergo propter hoc, Latin for with this, therefore because of this. In other words, putting things together whose connection is unproven. Take a medical example. A recent study of over 1 million women with breast cancer checked how many were cured by operations to remove suspected cancerous cells. It found that 2/3 were still alive 10 years later. It might seem natural to assume that the survival was due to the treatment, but the study also found that a control group of women given a mock operation, involving no removal of any cells, had an identical survival rate, plus greatly reduced risks or ill effects from the procedures. Be aware that in experimental studies there is a built-in bias to see causation, even when none may exist. Statistical answers or ideological hypotheses. Statistics aren't plain and simple facts. They're created, misunderstood, and manipulated, which is why politicians and businesses sometimes seize on them in order to present a partial picture. For example, a lot of research is based on probabilities, but working them out is something that even experienced researchers get wrong, perhaps applying the wrong statistical procedure to their data and generally overestimating the significance of their findings. Taking into account when a text is written. If a text is presented as a factual report or as research, the date when it was written can be crucial. The when is a vital bit of the context. Remember, first of all, facts keep changing. New discoveries are made, and old discoveries are revisited and found to have been mistaken. Astronomers only recently discovered that calculations and assumptions about the universe in the 20th century were way off, and that it now seems that 95% of the universe consists of so-called dark matter and dark energy, which is basically invisible. Views in many areas of science, and indeed the arts, are similarly in a constant state of refinement and modification. And then there's context. Huge events change perspectives long after. Something written in the politically optimistic years prior to World War I is going to be quite different from something written afterward. Likewise, the political background of the idealistic, hippie 1960s, the decade that ended with a man on the moon, compared to the late 1980s, the decade that ended with the collapse of the communist dreams of the Soviet Union, has a profound and maybe underappreciated influence on books, the pervading artistic climate, and culture. Judging the evidence. Offering evidence for a position is surprisingly easy. The real question is how you decide what counts as good evidence. For example, is a book with 10 pages of sources at the back better than one with no sources offered, like this one? I'll stick my head out a bit here and say, contrary to much academic practice, that the key thing is the main text. A source looks grand and fine, but the question of who says that and why is really just being passed on. It doesn't go away. Where did the author of the book used as a source get their information from? Authors should give as much evidence as readers need to make an independent assessment of an issue in the main body of the book. As a reader, you shouldn't be obliged to either take things on trust or to check up yourself on all the footnotes and sources offered in a library. Tip: the important thing is to give enough information to readers at the point they need it. Be suspicious of texts that are long on assertion and short on detail. A connected issue is the question of whether a book argues just one perspective or several. As I explain in Chapter 10, a good book needs to have the feel of a debate, carefully guided by a strong chairperson. For the critical reader, even if not for the general public, a book that presents opinions as facts and fails to indicate other views and approaches to the matter reduces its own credibility. Assessing your reasons for reading the text. It's amazing how many different responses people can have to the same text. So it's important for critical readers not only to think about the author's reasons for writing something, but also their own reasons for reading it. Tip: ask yourself how you first encountered the book or article. Did you just happen to come across it? Were you directed or referred to it? Or did it appear at the top of a systematic search, say by putting key words into an internet search engine? Is your source for the text anecdotal information, summaries of published works, for example on Amazon, or a newly minted academic reading list? The answers to these questions matter, because if, say, your source is something you just happened to come across, it may not be representative of the consensus of opinion on the subject. It may be the point of view of a small, activist minority, or just someone who doesn't really know their stuff. It's human nature to seek out views that reinforce ones we already hold, so beware of uncritical reading of articles and books you choose just because you liked the look of them. There's a thing called confirmation bias, which is our tendency to interpret new evidence as confirmation of our existing beliefs or theories. On the other hand, suppose that your source is a book that has been recommended to you by someone else. In such cases, the recommendation is only as good as their judgment. If they are a professor in the subject, yes, That's normally a good start, because they will surely have a good grasp of the general context. It's part of their job. But equally, they may have quite narrow, fixed views. You may be being steered toward a standard view at the expense of other, less conventional, but maybe more fruitful ones. The point is to always be aware that you could, and maybe should, be reading something else. Playing detective, examining the evidence. The Internet makes fact-checking any document incredibly quick and easy, although there are a lot of wonky websites, and you may make a worse mistake if you prefer a web page to a carefully researched book. But in any case, you need to look for several kinds of evidence when reading, of which facts are only the most superficial layer. Tip: uncritical readers usually think that evidence is about facts, but critical readers go a lot further. They don't read simply to discover facts. Like good philosophers, they know that the truth is anything but simple, and that any number of possible facts exist. So instead, they aim to critically evaluate ideas and arguments, aware that the important decisions in writing come in the author's selection and arrangement of the facts. Sometimes, everyone is wrong. For 1,500 years, one of the most widely accepted scientific proofs was Aristotle's proof that, wait for it, the Earth is motionless and at the center of the universe. Easy to mock now, but the brainy Greek philosopher argued that this must be the case. If you throw a stone straight up in the air, it comes straight down again. His reasoning was that if the Earth was moving, the stone would fall slightly away from where it had started. Another wrong but popular scientific theory was that dead or inanimate matter could quickly transform itself into living beings, just as the reverse can occur quite rapidly. This belief was supported by observation of common events, such as fireflies emerging from the morning dew, bacteria growing in sterilized broths, and small animals emerging from the mud at the bottom of ponds. Among the notables who endorsed this theory were Aristotle, yes, him again, Thomas Aquinas, Francis Bacon, Galileo, and Copernicus. In fact, as the saying goes, life is more complicated than that. A lot more complicated. Objects have a natural tendency to stop moving. Guess what? Aristotle taught this as a law. The mechanics of Aristotle was probably the longest-running wrong scientific idea ever, from ancient Greece up until practically Newton. One reason for their longevity was that they corresponded well to everyday experiences in the world around us. If you give a shove to something, it will start moving, but will soon stop. Another bit of standard physics was that heavy objects fall faster than light ones. It took Galileo to disprove this, yet he didn't do this by dropping rocks off the Leaning Tower of Pisa, as people mistakenly think, but rather by the irrefutable logic of a thought experiment. In this thought experiment, he imagined dropping balls off the tower. Finally, had you heard that all birds are stupid? For years, this was believed to be scientific fact, because early neurobiologists couldn't find anything in the bird brain that looked like human ones, and also because many studies focused on pigeons, which are not the most intelligent of birds. The scientists missed out that some birds, even some very everyday ones, are indeed pretty smart, like crows. Weighing up primary and secondary sources. In this section, I describe the detective work that critical readers carry out to uncover the hidden premises or chains of reasoning in a text. That is, the implied but not stated assumptions. Here are the differences between primary and secondary sources. Primary sources. Primary sources are a researcher's gold dust. They are original materials from the time period involved that have not been filtered through interpretation or evaluation. Primary sources present original thinking, present and report discoveries, or share new ideas or information. Secondary sources. Secondary sources are things like a piece of journalism or a book about someone else's opinions, research, or writings. They are interpretations and evaluations written in hindsight, but let's not be snotty about this. Hindsight is pretty powerful too. Think about the global warming controversy and just how many facts exist on both sides in the debate. If you look at different websites arguing over exactly the same piece of news, say that the Greenland ice sheet has been reported as shrinking, you can find two authoritative and equally factual explanations that come to completely opposed conclusions. Remember, how is this possible? In the global warming debate, as in many others, the selection of facts is what's important. That's why the critical reader doesn't just examine the evidence, but looks behind the facts too. Check out the earlier section, Reading Between the Lines, for a more detailed look at this. When reading a primary source, a short quote provides you with gold-plated evidence for your argument, as well as being more interesting to read. For example, if you are waiting for an author to prove to you that a newspaper called the Daily Whale once warned that polar bears were in danger of dying out, then a quote from the paper itself doing just this is much better than anything else, and certainly worth any number of experts recalling or remembering hearing that the whale often did such things. The Daily Whale would be, in this case, the primary source. Remember. However, to take the same article as proof that researchers believe that polar bears are dying out, let alone that they really are, would be to use the newspaper as a secondary source. The problem with secondary sources is simple. What you read is no longer what someone said, or, more subtly, the meaning may be different in the original context. The longer the chain of sources, the more likely distortions are to appear, as in a game of telephone. Tip: if you're reading someone's views of someone else's views, which is what almost all writing does come down to, count the author as being the authority, instead of trusting them to have accurately conveyed anyone else's words. For that reason, select the text that you use very carefully, very critically. How long before the coral reefs disappear? To believe the London Times, the answer to this question is any year now. In 2009, the paper devoted a supplement to warning against the rapid disappearance of coral reefs, which it attributed to the use of fossil fuels and the related emissions of carbon dioxide. The supplement contained an impressive range of graphs and glossy photographs of reefs prior to their destruction. The central argument was that the almost mind-bogglingly huge reserve of water comprising the Earth's oceans had become more acidic in the last 200 or so years as a result of industrialization and was poisoning the reefs. First of all, critical readers would note that the Times is acting only as a secondary source and communicating research by other people. Second, as a newspaper, the Times may well have a political interest that affects its reporting. In this case, the editor in charge of the supplement wrote elsewhere of feeling a duty to alert the world to the dangers of global warming, and that they had identified reefs as an issue with extra resonance. In other words, the report was serving a wider, more political purpose, to persuade governments to do more to reduce carbon dioxide emissions. As far as the science goes, coral reefs have been around about 500 million years, during which time the ocean's temperatures, acidity, and salinity have varied significantly. Many scientists argue quite different positions to that advanced, apparently dispassionately and authoritatively by the Times. Critical readers have to be suspicious of all claims, no matter how glossily and imposingly presented. Check the sources, cross-reference facts, and actively look for contrary reports. Then, whatever your eventual decision, it's much more solidly grounded. I'm interested in coral reefs and gave a paper to a conference in Queensland, Australia, on the topic of the Great Barrier Reef off Australia, which featured in the Times report. The reef was certainly in danger and suffering, but not from global warming. One obvious and observable threat came from the runoff of fertilizer, which contains nitrogen, from the huge farms in Queensland. Explanations for the damage that spoke of worldwide emissions of carbon dioxide, particularly by the Chinese, were politically convenient, whereas satellite images showing the nitrates sprayed by Queensland's farmers swirling out of the river estuaries towards dead and dying parts of the reefs were definitely not. Following chains of thought. Another way to be a critical reader is to strip texts down to their argumentative skeleton. What do I mean? Well, nonfiction texts consist of two sorts of arguments. Explicit arguments, signposted clearly in the text by discussing competing views and giving reasons why such and such is right or wrong. Explicit arguments often end up with marker terms such as in conclusion, therefore, and thus it can be seen. Implicit arguments. Just as important and, as the name implies, a lot harder to spot. There are many different ways to imply something, so these arguments come in many shapes and forms. For example, an account of the meltdown of the nuclear reactor at Chernobyl might include an implicit argument that nuclear energy is a bad idea. A newspaper story describing how famous pop singers cheat on their boyfriends or girlfriends might constitute an implicit argument that pop singers are all empty-headed people with no morals. Or, on the other hand, it might be written in a gushing, admiring way that implies that free love is fun and normal, at least for celebrities. All arguments, not just dodgy ones, are based on more assumptions than meet the eye. Check out the nearby sidebar, Breaking the Argument Chain, for an example. Breaking the Argument Chain. Euclid's axioms are rules for geometry, saying things such as parallel lines never meet, or things that are equal to the same thing are also equal to one another. Euclid believed that his axioms were self-evident statements about physical reality, meaning that you can see that they must be true by thinking about it. In fact, they can be faulted for containing hidden assumptions. For example, the one about parallel lines assumes that space is flat, because parallel lines certainly do meet if you draw them on a sphere. Try drawing two parallel lines on a football. Behind his rules are assumptions like the one that space is homogeneous, the same everywhere, and unbounded, which are necessary to ensure that any point can be transformed into another point by some mathematical operation, but not in themselves proven. Einstein, whose theory of relativity significantly modified Euclid's view by introducing the possibility of weird distortions caused by curved space-time, was a great critical thinker. And part of the reason why is that he was prepared to throw out so many of the assumptions everyone else took on uncritically. And yet his own theory contains lots of hidden assumptions, such as that one about space being homogeneous. The more powerful telescopes get, the less this seems to be true too. The matter in the universe seems to be distributed unevenly, It's important to realize that both Euclid and Einstein's geometries are right inasmuch as the theories follow logically from the assumptions they start from. Or, as the French mathematician Henri Poincaré once said, one geometry cannot be more true than the other. It can only be more convenient. Read me. Testing your critical reading skills. Here's a longish extract for you that I co-authored with Mark Schulgasser. Use this to practice your reading skills. Try to identify the important features and write your own brief notes on it, including a summary of the argument. Turn to the later section, Summarizing with Effective Note-Taking, for some tips. State whether the argument is persuasive and any other textual features you think need noting, such as dodgy argumentative techniques or hidden premises. Flip to the answers at the end of the chapter for my take on the piece. Philosophy has long had a dislike of astrology. It is, after all, irrational. And one of the most surprising, some would say alarming, facts about Ronald Reagan is that as soon as he became the President of the United States, he appointed a personal astrologer to help him make decisions. But then for thousands of years, all the kings and queens had their personal astrologers to do much the same thing. These were experts that they consulted on important state matters, such as when to invade the neighboring country, when to harvest the crops, or how best to bring up baby. Reagan had acquired the habit of consulting an expert in the occult arts when he was but a humble actor in California. Doubtless, the process helped him decide which role in which film he should accept. And we know where that ended. Breakfast with Bonzo, 1951. But once he took high office, the role of astrology became even more important. Reagan consulted his personal astrologer, Joan Quigley, about the personality and inclinations of other world leaders, and used these insights to help him assess the prospects of meetings succeeding. It seems, for example, that the stars looked favorably upon one Mikhail Gorbachev, then the leader of the otherwise evil empire, and hence Reagan was encouraged to attempt the rapprochement that in due course led to the end of the Cold War. In fact, the timings of all policy initiatives had to be squared with the movements of the cosmos, and White House staff were instructed to liaise with her in all their plans. She was responsible, in short, for the success of all that Reagan did. And these days, Reagan is counted as a pretty successful president, although that judgment is itself by no means necessarily a very scientific one. Of course, Ronald Reagan came in for a bit of a stick for consulting astrologers. Just as more generally scientists and attached pundits love nothing better than to mock more humble folk who follow their forecasts in the newspapers and magazines. For many educated people, nothing better illustrates the gullibility and foolishness of the masses and the need for the lead of a scientific elite than the continued activities of unlicensed specialists in the influence of the stars and planets on human affairs. They don't seem to remember or want to be told that for 1,000 years, universities taught astrology as one of the core subjects, and that it was part of a sophisticated system of medical knowledge involving the different parts of the body and different herbs. Even if that founding figure of sensible science, Isaac Newton, was brought up on a diet of esoteric knowledge, in which astrology ranked as one of the great studies of mankind, even if astronomy profited from the mystical approach of Pythagoras, even if the best of modern medicine is borrowed from herbalism, and chemistry is a side shoot of alchemy, even if, in short, in Paul Feyerabend's words, everywhere science is enriched and sustained by unscientific methods and unscientific results. Today, astrology is firmly fallen out of favor with philosophers, let alone scientists. Little remains of the subject other than the superficial popular and psychological forms. Yet, astrology, like many of the now much derided esoteric studies of the distant past, still has the potential to inform and underpin our understandings of the universe, because thousands of years of thinking are contained in those ancient astrological myths and legends. Science is just a blip in this long history. Spotting the hidden assumptions. Here's an argument that I adapt from Sam Harris, writer, commentator, and co-founder and chief executive of Project Reason, which says that it seeks to encourage critical thinking. Sam is convinced that science holds the answers to everything, including matters of right and wrong, and what's more, he thinks that he can prove it. He was so pleased with this argument, he offered a cash prize for anyone who could find a hole in it. Here is a summary of his argument, with my own clarifications. First premise. Notions of right and wrong, and human values in general, all depend on the existence of conscious minds, because only conscious minds can experience pleasure and pain. In other words, morality is rooted in awareness of pain and pleasure, which are brain states. Second premise. Conscious minds are natural phenomena, and so they must be fully explained and constrained, limited, by the physical laws of the universe, whatever these turn out to be in the end. In other words, consciousness is reducible to physical states, such as electrical signals or chemical changes in brains. Now Sam draws speedily to his knockout conclusion. Therefore, all questions concerning human values must have objectively right and wrong answers, and these answers can be obtained through the techniques of natural science. Sam adds, alert, weasel words, that he means this in principle, if not in practice. Okay, that's the argument. Now, what assumptions do you think are present that ought to be brought out into the light and checked? Answers at the end of this chapter. Filtering out irrelevant material. If only as much effort went into reducing words and arguments to their essentials as goes into producing and expanding on them, the world would be a less wordy place, communication would be enhanced, and knowledge would flourish like a well-pruned tree. Alas, the world isn't like this, and you need to be quite ruthless in hacking away at all the verbiage. In this section, you can find out how and why to make your notes effective and strategies to get your reading done in a fraction of the time you've been taught to do it in. Ignoring irrelevant material saves you time and effort and improves the quality of your work because it allows you to focus your efforts on what's genuinely useful. I discuss two tools in this section: effective note-taking and skim reading. Summarizing with effective note-taking. Note-taking requires you to use several key critical thinking skills: comprehension and analysis, synthesis, and writing and communication skills. Summarizing is the ability to make use of information, and it helps you to make sense of material. In practice, summarizing often involves reading a text or listening to a lecture. Yes, that's right, you can't avoid it. Identifying the elements that are most important or most relevant for you. Noting down these points in your own words. Organizing your notes clearly and effectively. The art of summarizing is in that last sentence. Anyone can write a summary. Writing a useful one is much harder. Summary tips. Tip: never let taking notes slow down your thinking or get in the way of your own ideas, let alone start to destroy your interest in the subject. Instead, actively follow debates and make any notes later. With books, you may well be better off reading the whole thing, or at least the chapter, and then whizzing back to jot a few notes. Wonderful thing, the brain. You find at once that most of what you may have noted before, you can now see isn't worth noting after all. The things that most cry out for summaries are books. If most books on critical thinking are careful to include chapter summaries and so on, many mainstream academic books don't do that. Instead, you have to read from chapter 1 to chapter Z, and maybe the index and footnotes too, to find out the author's point. That's not good. My own experience reading philosophy is that even the great works contain only one or two small ideas worth noting. I'm not making it up. After I read these books, or rather skim read them, see the next section, I usually find it requires just a few hundred words to sum up all the key points in a book of about 100,000 words. A few hundred words is a lot easier to write down, a lot easier to remember, and a lot easier to develop and take forward for your own purposes later. Don't be too dogmatic. If something is full of important ideas, your summary is going to get a bit longer. Tip: in cases where there is a lot of detail you really want to note, I recommend writing down an umbrella sentence to indicate what there is, and where, the page number, even the paragraph number, instead of specifying it. For example, if a book contains a series of biographies of famous scientists, write down that fact, with maybe a few of the names, but don't note any of the details, unless you won't have access to the source again. Remember, the key thing in summaries is that what you put in depends on what you want out. Don't summarize just for the sake of so-called completeness. You're almost certainly wasting your time, and what's worse, making it harder for you to develop the information later. Remember, while you're making notes, you can also be engaging purposefully and creatively with the topic, connecting up your own thoughts with the views of the author on the subjects. Tip: research shows that in higher-level work involving ideas and concepts, actively thinking about what you are reading or hearing and then paraphrasing the information, putting it in your own words, rather than writing it all down verbatim, makes it easier to recall later, say in an exam. And though they may seem scruffy and old-fashioned, handwritten notes are much easier and more likely to be paraphrased than those typed directly into a computer or laptop. Actually, even informal jottings frequently help you to find thoughts that you weren't aware of previously. When taking notes is done correctly, it is not a desperate effort to get down an accurate record of what's in the book or what the lecturer is saying. It is a much more constructive and personal activity. In effect, you discover your own ideas through the apparently reverse activity of writing down someone else's. Tip: P.S. Use abbreviations. The importance of factual notes. Okay, I know taking notes is boring. Much better to hope your brain remembers everything important and sorts out the information later subconsciously. Dream on. Unless you're very unusual, your brain forgets 98% of what you've carefully read and mangles the remaining 2%. That's where factual notes come in. Look on them not as a chore, but as a powerful thinking tool. A note acts as a safe deposit box that doesn't disappear overnight, and a page of notes is an organized store, too. Remember, notes should never be simply an abbreviated copy of the original text. They should be an attempt to pick out particular insights in the text. They're your signposts to the key ideas in what you've been reading. Using your time wisely. Skim reading. Skim reading is such a powerful technique. Strange that it isn't taught more. Indeed, teachers and professors usually insist that if they set a chapter to read, you better read every last word of it. But critical readers are an unconventional lot and can afford to risk the odd frown of disapproval. Remember, when skim reading, you read just the first 1 or 2 lines of each paragraph on the first page of any chapter. A website is a bit like a chapter in a book, and a web page is a bit like a paragraph. If none of what you read seems tempting, jump to the next chapter. If any of the paragraphs seem worth investigating further, keep reading at least until the next paragraph, and then check out the first lines of the following few paragraphs too. Only read sections of books that seem useful. And of course, you don't need to read them all, either. As I say, usually you can see whether a paragraph is useful to you by just reading the first line. As long as material seems relevant and useful, you keep reading, because you've struck gold. As soon as you sense the material isn't right for you, skim the first lines of the next few paragraphs. And if, to quote Mick Jagger, you still can't get no satisfaction, start flicking pages until you get to the next marked-out section. And certainly pause at a new chapter. When you seem to be in a useful part of the book, look more closely at the text than if you seem to be wading through irrelevant text. If, after about 2 minutes of skimming, the whole book seems a bit dull, stop and ask yourself, hey, why am I reading this? Maybe you could spend your time better. Tip: target your reading for the information you're after. For example, if an article's abstract provides what you need, skim the rest. Some writers say it all in the opening paragraph. That's actually a core journalistic skill. Some academics ramble around but express it pithily as a conclusion. Certainly, if all you want to know is a study's research outcomes, you don't need to read the methodology and context. Answers to Chapter 10's exercises. Here, I provide my thoughts on this chapter's 2 exercises. Read Me, testing your critical reading skills. I'm sure that you can find many things to say, but here are my notes. The piece is an informal argument. The author argues that something useful may reside in astrology and that it's too often dismissed. To back this assertion up, the authors give a number of examples. The first one is that of Ronald Reagan, who it seems relied on astrological advice for all his key policy decisions. A specific example is given. Reagan's decision to work with the Russian president to end the Cold War was based on advice from his astrologer that this would be a good policy. Another more general defense of astrology is that for 1,000 years, universities taught astrology as one of the core subjects. The hidden assumption, or implied premise, is that if something is taught at a university, it must be useful and important. The author adds that astrology was historically part of a sophisticated system of medical knowledge involving the different parts of the body and different herbs. The point isn't made explicit, but seems to be that astrology has aided the development of medical knowledge in general and herbalism in particular. But no evidence is offered for how astrological notions aided and guided herbalism, and so this seems to be argument by positive association, sometimes called the association fallacy. Similarly, the reference to Isaac Newton seems to be included more to associate a great scientist with astrology rather than to demonstrate anything more substantial about astrology's scientific usefulness. Here's one factual mistake in the piece that I spotted. The film referred to as Breakfast with Bonzo is actually Bedtime for Bonzo. This is a small mistake, but does cast doubt on the author's other factual claims. In summary, the piece presents itself as a factual argument, but seems to rest on subjective opinions. Spotting hidden assumptions. I think the argument is basically that morality is reducible to calculations of the total amount of human pleasure, as opposed to the amount of human pain, and that these sensations are also reducible to physical states, such as electrical signals or chemical changes in brains. Therefore, it seems reasonable to conclude that scientists can objectively measure and investigate such physical states. So, what are the hidden assumptions or implied premises? For starters, implied premise. Answers are right or wrong in science. This assumption is pretty large because science is a lot more complicated than this. Scientists, for example, tend to agree on a particular interpretation of data out of a range of possible interpretations. The agreements do not hold long. As one recent book puts it, surprisingly little of what experts held to be true even 20 years ago is still thought to be true today. And likely much of what's considered to be settled fact today will be adjusted in the next 20 years. Instead of giving right or wrong answers, science provides working hypotheses that are open to rebuttal later. Implied premise. Minds equal brains. An ongoing debate exists about whether minds and thoughts are the same thing as brains and chemical states. Clearly, a link is present, but one theory is that thought is a social phenomenon. What people think depends in subtle ways on what other people around them think, and on all the physical sensations that they're having and have ever had. Implied premise. Morality is simply a matter of maximizing pleasure and minimizing pain. This assumption barely fits any simple ethical test. Imagine, for example, a nasty neighbor who locks their family in the house and proposes to shoot their children one by one unless you agree to shoot yourself first. Sam would say that not only the scientifically right, but also the morally right thing is for you to do just that, because one dead person is less bad than two. But I'd say you are under no moral obligation to do so. No doubt, plenty more hidden assumptions exist, so don't necessarily count yourself wrong if you have a different list. Chapter 10. Cultivating your critical writing skills. In this chapter, structuring your writing for clarity, knowing and addressing your audience, walking your readers through the issues. This chapter is all about applying critical thinking skills where they belong best, in writing. You get an overview of how to write effectively, and also an inside view, as I explain the sorts of things that help to make writing, especially academic writing, clear, concise, and successful. In the process, you really get into the nuts and bolts of critical thinking. In this chapter, you can find out how to structure your writing to make its points clearer, as well as about the who, what, and where factors that are vital to guiding your arguments. I dish up some tasty tips on preparation and research, and describe how to home in quickly on the textual clues in writing, by being aware of the key terms. Finally, and that's a straightforward textual clue to flag the end of these introductory paragraphs, you have an opportunity to develop your argumentation skills by deconstructing a passage into its constituent, logical parts, and specifically its intermediate conclusions. Intermediate whats? It sounds like jargon, I know. Indeed, it is jargon. but the concept is useful and intermediate conclusions matter. You can find out all about them in this chapter. Structuring your thoughts on the page. By definition, a solid structure provides support for your piece of writing and gives readers the best chance of grasping your point or argument. In this section, I cover the basics, showing how to handle evidence and how to make sure that you really answer the question in an exam or assignment. And it's all sprinkled with some essential tips on structure from an expert in the critical writing field. Identifying the basics of structure. What are the ingredients of a well-structured piece of writing? Well, writing first things first is a great start. Remember, you confuse readers when you don't tell them your overall position early on and up front. I know that keeping a few tricks up your sleeve is more exciting, or even better, like a detective story, subtly leading readers into believing something that's the opposite of what turns out in a dramatic final paragraph to be the case. But it is confusing. Also, in the context of factual writing, revealing your position at the outset is more honest, because then readers can critically evaluate your arguments. For instance, if you're going to present an argument that Shakespeare was actually an Inuit from Greenland, say so early on, and then readers can be duly skeptical of any incidental details your essay starts to dwell on regarding textual evidence of Shakespeare's deep interest in snow and ice. Another part of structuring your writing is to keep related information together. Suppose you're discussing the health effects of pollution, and you have 3 points about the ways that cars create dangerous fumes. At the very least, consider whether to group the points together. Sometimes, of course, you may have good reasons for keeping them separate. A book's index often reveals how methodical and organized the author really is, and how well they have grouped connected material together. If key topics in the index are revealed as page sweeps, such as 34 through 41, this is a better sign than if the same specific theme turns up in 10 or 20 different locations in the book. Tip: view an index as a kind of X-ray of a book that reveals its hidden structure. Try indexing some of your own longer pieces of writing. You may be surprised to see how scattered your thoughts are. Even easier and quicker to do is a computer search of your document for certain words. Do you keep mentioning paradigm, for example, or have too many buts and howevers? X-ray your own work by checking for key terms. Sometimes the check reveals problems. Warning: what about layout and graphics? After all, isn't a picture worth 1,000 words? Well, maybe for writing holiday news, but not in critical writing. No, no, no. Don't use graphics to prove your arguments. Critical writing isn't marketing. Use graphics only to illustrate ideas that you've presented first in the main text. Similarly, don't rely on headings or snazzy fonts and text styles to make your points. But you can use all these things to highlight ideas and signpost things to the reader. That is, after all, what a For Dummies book is doing all the time. Look at the next heading. Doesn't it help you quickly navigate the text? Presenting the evidence and setting out the argument. In critical writing, the emphasis is on producing reasons to support, or equally important, to discredit, a position. Evidence is crucial for both kinds of activity, although clearly you need to produce more evidence for controversial claims than for common-sense assertions that your readers may reasonably be expected not to need convincing of. Warning: leave inessential background information, anecdotes, or jokes, useful as they are for reaching word targets, to Internet chat rooms. Likewise, statements of personal opinion don't fit in with the central idea of critical writing, which is to persuade through argument. Writing comes in all shapes and sizes, but the essay format is often the way in which colleges demand it, and so I concentrate on that style here. Academic essays are supposed to argue a certain position and provide reasons that support a conclusion. Thus, they are critical thinking in capsule form. Let everyone have their say. In essence, your job in critical writing is to allow a real debate and properly air views for and against issues. It's not to settle the issue once and for all. Even Einstein, in writing his famous Theory of Relativity, didn't seek to shut down the debate. He recognized that what he was producing might be flawed and invited his readers to keep testing and exploring the issues. Indeed, some of them spotted key errors in his math, the part that's normally supposed to be pretty black and white. Einstein had to revise his equations many, many times. He also proposed tests other people might make to see if his theory worked, like checking during a solar eclipse whether or not the sun bent the light from distant stars. You can propose ways to test your theories too, but be prepared to be proved wrong. But, like life, an essay is more complicated than that. In critical writing, you need to make a particular effort to identify conflicting positions and to acknowledge different views. A sophisticated essay shows how the conclusions follow from the evidence provided, but it may also explore issues and arguments related to the question that don't support the eventual conclusions. In this important sense, a good essay consists of several arguments, some of which are in competition with each other. Tip: I hear you saying, "Hold on there. Surely the aim is to write only what's strictly relevant and right." But remember that interpretation is the key in critical writing. You don't need to show either how good you are at rote learning or even how skillful you are at reinventing the wheel. Instead, in most cases, your job is to examine other people's ideas and select from them the elements you need. And don't be dogmatic. I say dogmatically. Respect different views and approaches, and display a spirit of negotiation in your critical writing. Checking out the key principles of well-structured writing. Writing well requires three things: knowledge of your topic, organization, and communication skills. In many academic contexts, the last one is the Cinderella skill, not invited to the party. In this section, you can learn how to make all three elements come to you as naturally as breathing. Andrew Northedge is an expert in this area, and here, to get you started, are some of his most useful points for his students. Knowing what you're writing about. Andrew Northedge, a professor emeritus at the Open University in the UK, specializes in writing guides for students, which include lots of ideas relevant to critical thinking. The Open University is different from other universities in that its students are a mix of ages and backgrounds, often studying part-time, and the courses have to be delivered at a distance rather than in person, often via the Internet. Getting students to think critically is thus a particular concern of the Open University. Northedge urges students to spend a bit of time before they start writing to ask themselves just what they're meant to write. In other words, to try to identify the topics, information, and ideas that a tutor, or more generally future readers of the essay, will be looking for. This may seem obvious, perhaps, but as Northedge says, writing is a particularly private activity. People retreat into a quiet corner on their own to do it. And if students spend a lot of time thinking about their own writing, and a bit of time thinking about the feedback later from tutors, most students never see what anyone else has written during their course. They live in a bubble, and their writing is sealed off from public view. So make a special point of peering out. Doing initial research. Tip: carry out some broad-brush preliminary research before you write. Don't just look up a few bits you need and plonk them in the writing. Instead, search for background material that allows for thinking and reflection. Yes, I know it takes up valuable time, but just like painting a wall, if you spend half an hour preparing, you often save several hours later, or at least that half an hour. Preparing before writing means reading about your subject, thinking about the issues, making notes, and perhaps doodling some ideas. Check out chapters 9 and 11 for more on this invaluable skill. All this work improves your writing and makes your arguments more effective when you commit your ideas to paper. Taking lessons from others. Tip: talk about the subject of your essay with other people, specifically those doing similar subjects, and perhaps ask to look at some of their writing for ideas on style. Of course, if you're a student doing an assignment, maybe don't look at essays on exactly your topic, or if you do so, make sure that it's after all the essays, yours and those you might be looking at, have been marked. Otherwise, you're in danger of looking like you're copying ideas. However, if your pieces of writing are regularly criticized for lacking clarity and structure, which is a vague sort of criticism and hard to act upon, comparing your efforts to those of someone whose writings have been praised for just these sorts of features can give insights. Then, when you start writing, aim for simplicity and elegance over grandiose constructions intended to be huge and imposing. Andrew Northage sums it up as follows: there's no great mystery about what is good writing and what is not. Good writing is easy to read and makes sense. Poor writing is unclear and confusing. It keeps making you stop to try to work out what it's saying and where it's going. Andrew Northage, The Good Study Guide, 2005. Reworking that first draft. When you've written your first draft, you arrive at the often neglected after-writing stage. No, not turning the TV on, putting your feet up, and getting the beer out. It's now that the real work begins. Tip: Professor Northage's tip for this stage is to spend time on improving the flow. He means mainly ensuring that the paragraphs flow in a smooth sequence. He recommends adding in extra text at key points that helps readers by tipping them off in advance where the argument is heading. Check out the later section, Spotting and Using Key Words, for more details. But just saying what the next paragraph is about isn't enough. You need to have a reason for your choice of content, too. A sensible plan guiding the writing overall. The topics need to follow on from each other coherently and logically. To make sure that this happens, you need to either be very good at writing off the top of your head, what's sometimes called stream of consciousness writing, the optimistic idea that your subconscious does all the work for you, or to have a pretty detailed and careful draft outline to guide your writing. You won't be surprised that for most people, a separate plan, one that delivers a sequence of points for the essay, together with links that connect them one to the next, works best in practice. Linking can seem a subtle concept, but it's not difficult. It simply involves using certain words to connect your paragraphs. Suppose you're writing an essay on the prospects of a manned base on Mars in the next decade, and your paragraph ends with the observation that the Mars base will require protection from meteorites. Then the next paragraph really needs to follow up this issue, perhaps by talking about meteorite-proof domes or about other problems. When the essay changes direction, you can start the new paragraph with a few link words, such as, another practical issue for any future interplanetary base may be. Such writing tricks are so easy that people often take them for granted, yet they can make all the difference between readability and indigestibility. Remember, most people can always identify good writing because only good writing is interesting, effective, and informative. For this reason, a vital part of critical writing is critical reading, because you have to be able to read and reread your drafts with a critical eye before you're going to be able to improve them. Deconstructing the question. Tip: essay titles and assignment questions matter. Think of them as introducing you to an audience with a very particular interest. Imagine, for example, people who have paid to hear a talk on how to grow tomatoes. They're not going to be happy with one about the merits of ketchup over brown sauce. The critical thinker's first job when writing is to think through exactly what the interest is, and all of the implications of the essay title or question. Don't tell the audience what you're interested in. Tell readers only about what they want to know. The title or question is your indispensable guide to that. Warning: critical thinking involves close examination of texts. Yet, students often spend surprising little time on the very short and easily underestimated line or two that comes in the form of the question or assignment. Yet if you settle for a general impression of this short text and charge off in the wrong direction, you can waste a lot of time and effort. Much better to deconstruct the question carefully, noting the choice and special significance of the words and assumptions behind it. In the academic context, the need to answer the question is paramount. As Andrew Northage, the British college professor, stresses, everything in an essay should relate to the question. And what's more, you need to make clear that this is the case. Northage sees successful essays as featuring one long argument with every paragraph leading inexorably to and supporting the conclusion, although that could be that there are no simple answers. Producing effective conclusions. A crucial part of structuring an academic essay is ensuring that your conclusion is effective. Tip: don't just answer the question, but make clear that you've answered it. And the "it" must be the original question. Yes, this advice sounds obvious, but in colleges anyway, the answer is only right if it matches the original question. Often it doesn't matter whether you agree or disagree with the question under examination or in the title, or if you conclude that there's no answer, or that it all depends. But absolutely, without exception, you have to make clear and unambiguously that your conclusion follows from the evidence you've presented and deals with the point you set out originally to explore. So, when you write the conclusion, don't worry about insulting the reader's intelligence. Just go right ahead and spell things out. The same applies for all your earlier subsidiary points too, your intermediate conclusions that build up to your final one. More on these in the later section, using intermediate conclusions. Choosing the appropriate style of writing. Critical writing requires keeping your audience in mind constantly. Therefore, you need to select the right information for them and present it in a way that's appropriate for them. avoiding unnecessary technicality or jargon. Keeping your audience in mind. Remember, it's only common sense that different kinds of writing are aimed at different kinds of readers, and for sure, critical writing is expecting critical reading later. But it's important to target a readership that is essentially imaginary. Be careful not to aim at too narrow an audience. What you don't do, for example, if you're a student asked to write an essay entitled, "What's the Root of the World's Problems Today?" is produce an essay arguing in favor of a radical redistribution of wealth and against cruelty to animals, just because your teacher is a sandal-wearing vegetarian who hates rich people. No, not at all. You address not your supervisor, but, at the very least, all the people the supervisor would expect your essay to need to convince too. For a student, rather obviously and literally, this would be examiners. But examiners, too, stand in for a wider audience. On a topic like this, they'd judge an essay to be convincing and persuasive only if it would persuade an educated and reasonable person. That said, another thing to avoid is writing for someone who is supposed to have just read, very carefully, the same thing you have. Lots of academic writers do this. In fact, it's a kind of academic style. So academics may say things like, Peirce's central argument is essentially utilitarian with additional elements of phaneroscopy. Professors who write like this seem determined to chuck out all the people who aren't sure who Peirce is, then those who are confused by the word utilitarian, and to finally club the last remaining reader into a coma with the completely obscure term phaneroscopy. People who write like this are essentially writing for no one, so don't do it. Of course, you may need to introduce specialized ideas in your writing, but do so in a more conversational way. For example, our unintelligible sentence just might become, the American thinker Charles Sanders Peirce argued against prevailing views that human lives and actions are constrained by forces outside their control, by suggesting that humans can imagine anything they like, and any idea can be useful, just as long as it is capable of being tested in practice later. What I've done here is briefly introduce Peirce, then give a very quick summary of the context, and finally get to the point, all in plain language. You may note that I haven't said what phaneroscopy is, but there's a reason for that. It really doesn't need to be mentioned. It's an obscure term, jargon, that the reader can be spared completely. Guess what? It takes longer to write a clear and informative sentence than an obscure and unhelpful one. You may indeed have to stop, go back, and research your own words. Yes, you may have to check what you wrote, just like boring teachers say. And they're not trying to get to the ball game /watch TV /eat pizza. But the deal in writing is that you, the writer, do the work, and the reader gets the benefits. Too often, some writers imagine it is the other way around. That said, the judgment about audience, however, is far from being as simple as just writing for some monkish wise person. You need to consider the whole range of particular factors. For example, if you're writing about a student dissertation for a supervisor in China, or India, or Saudi Arabia, you shouldn't assume the same shared base of political opinions as you maybe can when writing within the UK, Western Europe, or parts of the U.S. If you're writing a notice for the local history group, you can assume certain names and specialized terms are already well understood. Considering the detail required. Any question set by an exam board or a tutor comes with certain expectations of the level of detail wanted and about background knowledge within a certain subject domain, plus important assumptions about the style of writing. I know from personal experience that writing an interesting and highly creative narrative on a topic is pointless if the examiner wants a demonstration of knowledge of certain particular points. Dull, maybe, but that's how it is, and critical writers are nothing if not realistic. To work out the relevant domain of expertise, to use a flowery phrase, ask yourself, what's the practical context? For example, if you're writing an essay on what role organic farming can have in feeding the world, you need to identify the appropriate framework. Is the context a course on economics, farming technology, or social psychology? Or perhaps it's not a course at all, but an assignment for a company making, say, organic ice cream. Tip: the topics and evidence you look at in most detail depend on the key audience you're writing for. See the nearby sidebar, Types of Audiences, for more information. Apart from content, though, think structure. Student essays, for example, aren't exactly journal articles, let alone full-blown dissertations, thank goodness, but they're a specialized, highly structured kind of writing that must focus on developing an argument. Tip: a good way to road test your writing is to write your conclusion down, and then write the opposite. Now, can you quickly find in your piece of writing the key points that you can read out to dissuade anyone arguing this opposite position? Types of audiences. Here are some general approaches for particular types of writing aimed at specific audiences. Academic studies and report writing. A summary usually starts this kind of writing, and the main body of the report usually follows a set pattern. A section outlining the problem, a section that explains what people have already said about it, and the all-important research methods section. This latter section is where the author explains why they've chosen to go about exploring the issue, whatever it may be, in a certain way. The bulk of the report then concerns an account of what was found out using this method, and the final sections concern the conclusions being drawn from this research. Journal articles. These usually begin with a separate summary called the synopsis, and the main body starts off by looking at the context of the issue and examining several possible positions, all taken with very detailed referencing. The final paragraph may well be called conclusion, and that's what it is, drawing together the threads of what has been discussed earlier. The synopsis and the conclusion of many academic journal articles are very similar. Magazine article. These may well start with a little story or a teasing question, which is followed by a discussion that gets more detailed as you read on, and may well end up with a surprise at the end. Newspaper article. At least conventionally, these start off by stating all the key points in the first line. The second paragraph then expands on this opening, and the article itself consists of the same again in more detail. Newspaper articles don't save the best bit until last because for practical production reasons, the end of the article is the first to be cut if space is a bit tight. Old-school journalists used to be told always to structure stories the same way, to say who, what, when, where, why, how, in that order. Don't dismiss journalistic writing. Journalists are experts in putting things clearly and concisely. Their writing is structured, sources are smoothly given in the main text, and it shares one important feature with academic writing: the search for impartiality. What you see is news. What you know is background. What you feel is opinion, as the American journalist Lester Markle said. Getting down to the specifics of critical writing. At the start of this chapter, I promised to cover the nuts and bolts of the critical writing skills. So now, here they are. It all hinges on strategies for straightforwardness, keywords, evidence, signposts, and conclusions. Understanding that only gardens should be flowery. Tip. Rule number 1 of critical writing is to keep sentences short and simple. Doing so is easy, and it's a mystery why many people seem to prefer writing long, complicated sentences that introduce ambiguity and are tiring for readers to follow. They oblige readers to retain in their memory, at least briefly, one part of the sentence while they struggle to process the next bit, or the bit after that. Rule 2 is to avoid specialist terms and technical language where possible. And where you do need them, clearly introduce and explain them. Similarly, flag any non-specialist terms that can be used in more than one way as ambiguous, and define them for the purposes of the essay. A good way to road-check the comprehensibility of your writing, or at least of certain phrases, is to read it aloud. Remember, you don't have to appear to be a know-it-all, so simplify wherever possible. Spotting and using keywords. Keywords emphasize or indicate the focus or intentions of the writer. They ask the readers to think in a particular way, specifically to anticipate what's about to happen next. The use of appropriate keywords makes your writing much more effective. Okay, so keywords are worth using, but which ones are they? Not all words are equal. Part of writing effectively is certainly to use a relatively small number of powerful words, in the sense that they help to shape your argument and guide readers through it. Warning. Between you and me, quite a bit of nonsense is sometimes written about critical thinking keywords, which in no way fits with real language and the kinds of things that people read and write. For example, when you read a journal article, you're unlikely to find a phrase such as, "I will start by arguing," but many critical thinking guides call this an excellent syntactical device. Similarly, some lecturers forbid their students from writing, "Finally, in conclusion," but some critical thinking guides earnestly assure their readers that this is part of constructing a good essay. No, the truth is a bit more subtle. A lot of the navigation of writing is implied, such as that the first paragraph is probably going to introduce the topic, and the last one is probably the conclusion. Tip. With that cautionary note in mind, here are some patterns in writing that you need to be aware of. Keywords flagging another argument in support of a view. Similarly, equally, again, another, in the same way, likewise. Keywords flagging alternative perspectives and arguments. On the other hand, that's one of my favorites, yet, however, but, not to forget, also a favorite, in contrast to. Keywords pushing back against a criticism just advanced in support of an earlier view. Nonetheless, even so, however, but, yes, keywords can serve different purposes. Keywords telling the reader that you're about to draw some conclusions. Get ready. Therefore, thus, for this reason, because of this, it seems that, in summary, presenting the evidence and setting out the argument. Particularly in the academic context, where issues are complex and approaches can differ widely, a written essay is like a spoken debate, with several speakers presenting their positions and having to justify them too. Your role, as the author of the piece of critical writing, is to chair the debate asking searching questions, and, most exciting of all, ruling on whether the speaker has met the objection or is starting to digress. Remember, a skilled critical writer, like a good chairperson in a meeting, always wants to make sure that all the important issues are at least aired, and also knows how much space to give to each position, while not forgetting the need to rein some people in, to keep them to the point. So, critical writers need to argue one thing one moment, then another contrary thing, and at any point change their tone and their mind. They have to think for several people all at once. It requires them to become almost schizophrenic. Plus, they continually try to judge the whole situation as reflected in what they've just written. Warning: the danger always exists that a piece of critical writing can degenerate into a babble of different opinions, all competing for the reader's attention and appearing not to relate to each other. At worst, such writing not only seems to be, but actually has become an unstructured mess. Remember, as in a debate, the key thing in critical writing is to have a good chairperson. Someone has to be in charge, and guess what? It's you, the writer, who has been made the all-important chair of the debate. Use that authority. For example, in critical writing, as with a live debate, one position can triumph over another, maybe by producing a killer fact, or maybe by demonstrating a contradiction in the opponent's logic. It's your role to rule on those points for the reader. Avoiding commitment with weasel words. You may be surprised to discover that weasel words aren't always a bad thing. They have a good side, too. In essence, it is best to avoid absolute language altogether unless you can back it up with solid data or strong evidence. Critical writing recognizes more than one explanation for everything, correction for most things, and so introducing a little bit of flexibility into your writing avoids committing yourself unnecessarily to more sweeping opinions than necessary. For example, write "in many cases" instead of "every." Don't say every cloud has a silver lining, but argue that sometimes a cloud has a silver lining. Never write never. Use rarely. Don't insist that an earthquake has never happened in the UK. Just argue that there have rarely been any large earthquakes in the UK. The word large is also a way of finessing the claim. In general, don't try to prove your point, just tentatively offer it. So instead of writing "this proves" or "I have proved," write "this indicates" or "the evidence presented here suggests." Signposting to keep readers on course. Give directions. Use signpost words to guide your readers. To introduce a new idea, write phrases such as "first of all" or "some recent research shows." To back up something already mentioned, use words such as "similarly" or "indeed." To indicate a change of direction and introduce alternative perspectives on an issue, use phrases such as "on the other hand," or words like "equally" and "nonetheless." Paragraphs are another great tool to help readers navigate your writing. Ensure that each paragraph deals only with one idea, and in a similar spirit, aim to give each idea its own paragraph. Remember, some ideas, of course, require several paragraphs, but in that case, each paragraph represents a slightly different aspect of the discussion. Deal with each idea in its own paragraph. Use the first line to signpost the contents of the paragraph. Arrange the paragraphs in a logical sequence. Using intermediate conclusions. Many arguments contain within them smaller arguments, sub-arguments. When the conclusion of this sub-argument is needed for the following larger argument, they're called intermediate conclusions. See Figure 10-1, which can be found in the print and e-book versions of this book. Providing sources with references. Here's some good reasons why you should use references in your writing. Honesty. You don't want to steal anyone else's ideas. Give credit where credit is due. Helpful. Readers may want to follow up what you're saying. The reference points them the right way. Scientific. The reference provides more detail on what you're claiming is the case. People can then check whether you're putting the position accurately, and much more than that, they can check the arguments offered by your source. References are useful to writers, too, because they remind you where certain ideas came from. They can even help you avoid common pitfalls in writing, such as committing yourself to out-of-date or plain wrong positions, as well as providing a quick way to check or expand on things you've written about. But be critical about your own sources and demonstrate that you're doing so in your writing. Who are these other authors anyway? Why should readers take their word for anything? So, intermediate conclusions are, surprise, surprise, a kind of conclusion. But they're also propositions, the series of claims in an essay about the world, about facts or logical relationships. In romantic novels, a proposition is usually someone asking for sexual favors, but critical thinkers aren't interested in that kind of proposition. Often, a proposition is the length of a sentence, but propositions and sentences don't necessarily correspond. A sentence can easily contain several propositions. For example, the sentence, "Eating sugar makes children fat and rots their teeth," is really two propositions. Consider, for example, that eating fried foods will make children fat but not rot their teeth. On the other hand, some propositions may be spread over several sentences. In an essay arguing for a particular point of view, the author will often simply assert at least one, but more usually two or three propositions, which together make up the premises or starting assumptions, and provide another proposition as the conclusion. Remember, in between, however, the piece of writing may contain several intermediate conclusions that are derived, directly or indirectly, from the premises. These intermediate conclusions have a special character. They're supported by reasons, and themselves lend support, acting as a reason for the main conclusion. Intermediate conclusions are both the premises for a new argument and the conclusions of an earlier one. They're like stepping stones to the main conclusion. In fact, you can strip down a successful essay to just the propositions, P, intermediate conclusions, IC, and final conclusion, FC, identified perhaps as P1, P2, P3, IC1, IC2, FC, even if this means throwing out everything that made the essay colorful, readable, and fun. As far as the logic goes, it wouldn't matter. This exercise, which I call Intermediate Conclusions on the Moon, makes this point clearer. Strip the following short passage down to its premises, intermediate conclusions, and final conclusion. Answers at the end of the chapter. If humankind is to survive an all-out nuclear war on Earth, then people must be prepared to create colonies on the Moon. However, the Moon is a hostile environment. For a start, it contains very little water, and there is no breathable atmosphere. It may be possible to import from Earth a certain amount of material to create a base, but from then on the base must be self-sufficient and able to continually recycle everything humans need to survive. Unfortunately, experiments with sealed communities in the desert on Earth have shown that there is always a degradation and loss of minerals and nutrients in such biospheres. Therefore, the only way for a long-term moon base to survive is for the astronauts to mine the surrounding rocks for minerals and water. Recent measurements by orbiting satellites indicate that the moon likely has adequate reserves of everything that a moon base may require, and so the dream of man on the moon is perhaps not so far-fetched after all. Answers to Chapter 10's exercise. Here are my answers to the Intermediate Conclusions on the Moon exercise. If the exercise was presented as a question, it would be something like, is a moon base a realistic proposition? Then the structure of the argument seems to be as follows. Premise: people may need to create colonies on the moon. Premise: the moon contains very little water and has no breathable atmosphere. Intermediate conclusion: therefore the base must be self-sufficient and able continually to recycle everything humans need to survive. Premise: experiments show that biospheres always feature a degradation of resources. Intermediate conclusion: therefore the only way a moon base can survive is by mining the surrounding rocks for minerals and water. Premise: the moon has adequate reserves of everything that a moon base may require. Final conclusion: a moon base is possible. Chapter 11. Speaking and Listening Critically. In this chapter, loving lectures and succeeding in seminars. Taking effective notes. Creating the right atmosphere for debate. Critical thinking is an active, questioning activity that inevitably involves speaking and listening critically. In order to communicate your own ideas and views effectively and to appreciate and analyze those of others, you need to interact with people, hearing what they're saying and responding clearly. In this chapter, I suggest ways to make lectures, seminars, discussions, and meetings, all kinds of activity where speech predominates, more productive. I discuss the pros and cons of formal lectures versus less structured methods of learning. Despite my reservations about lectures, I include some practical strategies for getting more out of them and ways to extend critical thinking not only from what you read and write, but also what you hear and even what you say. I show how note-taking and even doodling can provide the crucial missing interactive element. And don't forget, because this chapter has a polemical edge, you can practice your critical thinking skills by weighing the arguments I present. Getting the most from formal talks. When you're reading or writing, you can at least take a little time to be properly analytical and organized. Not so when you're talking, or indeed when you're trying to keep up with what someone else is saying. This section is all about how to get straight to the heart of issues in real time. That is, how to keep up with live arguments and debates in the academic context of seminars and lectures. It will give you some insights into how to deal more effectively with the ideas and information presented. Whether you're a student or a teacher, an employee or a boss, you will sometimes need both to take in detailed information delivered verbally and to explain things on your own behalf to others, perhaps individually, perhaps in groups. Most people will have been brought up with really just one model of communication, the lecture style, which dominates education from age 5 onward. And I mean onward, because even PhD students spend most of their time passively taking in information delivered by specialists. However, formal lectures are a very inefficient way to convey information and ideas. Yes, talks can be both fun and informative, but in the world of business, the assumption is often that if someone has been paid to give a talk, then they better do just that and share as much of their expertise as possible in the time available. And many professors seem to think the same way. Yet when a speaker is essentially delivering the kind of information that could have been turned into a handout for the audience to read at their leisure, and where the audience is earnestly trying to put down on paper the lecturer's words, the approach becomes pretty absurd. Remember, nonetheless, the formal talk or lecture does have its role, which is when the talk goes beyond a written document. The easy way to achieve this is with visuals, maybe a PowerPoint. Multimedia tools can really boost both a formal talk's appeal and its usefulness. But another important way to achieve this goal is to be interactive and responsive in your talking. The best lecturers are like actors on a stage, totally aware of their audience. I've known some who even managed to perform like stand-up comedians, which might sound rather frivolous, but believe me, a lot of information can be conveyed using humor. Don't underestimate wit, whether dry or wacky or whatever, because jokes are intellectual can openers, offering surprisingly powerful insights. For Dummies critics who think books that adopt a light tone are less informative than the ones that just plod monotonously on are plain wrong. No serious talks should be, well, serious. Don't you believe it? There's a reason why so many of the brainiest people in science like to crack jokes. Because when you think about it, a good joke demands a very special kind of deep thinking, a kind of world-upturning, no-holds-barred problem-solving. It's the same skill that produces the great insights of art and commerce, the insight that sees solutions and creates opportunities. And yes, such skills can be approached through exercises and study, but I'm not sure there's any reason to think such sensible methods work any better than having a sense of humor. So why not, at least for a moment, throw conventional thinking to the wind and re-examine whatever it is you're looking at through a very special prism of jokes and riddles? Take a look at the nearby sidebar. Sherlock Holmes goes camping to see a joke I've used to make a point about the limits of logical thinking. Of course, don't go over the top. There's nothing worse than a joke that falls flat. But a little bit of dry wit is one way to keep the attention of audience members and to have a genuine interaction with them. Sherlock Holmes goes camping. Critical thinking books tend to elevate abstract kinds of logic over everyday ways of making connections. Here's a little joke, one of the kind you might liven up a lecture with, to illustrate that. I've put it in my own words. You should too if you use it, but as with all jokes, someone else thought of it first. The famous detective Sherlock Holmes and his indefatigable assistant Dr. Watson go on a camping trip. In the middle of the night, Holmes, ever a light sleeper, wakes up and stares up at the night sky with thousands of stars twinkling down on them. Renowned for his powers of deduction, Holmes leans over and nudges Watson. "Watson, wake up. Look around and tell me what you see." Watson rubs his eyes and says, "Well, Holmes, I can see many uncountable millions of stars stretching away as far as the eye can see." "And what do you deduce from that?" "Why, that the universe is incomprehensibly old and vast." "Very good, Watson. Is there anything else, though?" Well, Holmes, yes. Meteorologically speaking, I deduce that tomorrow will be slightly warmer than today with fine, clear skies." "Excellent, Watson. But is there anything else, perhaps more practical, that we can deduce immediately?" "Certainly, Holmes, we can deduce from the position of the Great Bear that it is now a little after 3 a.m. Now, what, may I ask, do you deduce, Holmes?" And then, please, can we go back to sleep? Watson, you fool, the wind has blown our tent away. The philosophical takeaway here is an invaluable one. Understanding the world hinges on having first adopted the right kind of perspective. It's a lesson that is also central to critical thinking. Warning. Humor, visuals, basically just being interesting, are all things that can improve attention spans. But then there's retention of the content, too. It's only human to remember the fun bits and forget the rest. Teachers and professors often complain that their students fail to remember what they've been taught from one week to another, that they forget what was in Chapter 1 by the time they are at Chapter 3, and so on. More sophisticated educators may bemoan the inability of students to transfer what they've studied from one context or problem to another. Why do students struggle like this? In fact, the fault may lie more with the teachers than the students. Most learning follows a hierarchical model where knowledge is delivered by an expert to students, who are supposed to record it passively on paper and ideally commit it to memory later, certainly before the exam. Yet, here's a paradoxical thing. Rote learning, that is passive learning, is inefficient learning because the brain hates disassociated information. Facts and ideas are best digested when they can immediately be put to use, which is why a well-chosen question in a lecture can help listeners to sort out what they think and both organize and retain it better. It is this ability to sort information, to create mental links between different things already learned, and most of all, to have the kind of brain ready to see new links and possibilities that critical thinking encourages, and for very practical reasons. Plenty of research studies, although to be fair, certainly not all, find that lots of high-achieving students who just soak up facts and figures on no matter what, and thus excel at exams, have a very hard time when faced with real-life issues and problems in their working lives, because they have not developed the more important meta-skills of actively processing information. Things like those presented by Marty Neumeier, whose background is in design thinking, in his 2012 book, Metaskills, 5 Talents for the Robotic Age, feeling, intuition and empathy, seeing, systems thinking, dreaming, applied imagination, making, designing, and learning, especially by teaching yourself. Suppose you have to give a 5-minute presentation on the topic effective communication in the context of leading a student seminar. Obviously, you'll need to practice what you preach. So what would be a nice, entertaining way to start off the presentation? Skip to the end of this chapter for some possible strategies. Hint, you might start with a question, but what would be a good one? Or you might start with a joke or personal story, but again, what sort of joke or story would fit the context? Participating in seminars and small groups. The latest research on teaching emphasizes that the best teachers say the least, though you'd hardly know it. The model of a subject expert giving a lecture is pretty hard to uproot. Thank goodness for that alternative way of learning. Seminars. Remember, a successful seminar is one in which the leader prepares the environment for everyone else to enter into real discussions. The only role of the group leader is maybe to ask questions, but these are open-ended questions, not ones with preconceived right or wrong answers. The leader may also act as a little bit of a facilitator, perhaps dampening down the over-enthusiastic tendencies of some students to dominate, and gently ensuring as wide a range of contributions as possible. Tip. A smart tip for making the most of academic seminars is to participate in the pre-seminar activities. Nothing too racy, mind, more like reading the set texts or researching the topic. Remember the Scout motto, be prepared. So, how do you get the most out of a seminar or similar small group discussion? Of course, the short answer is to be prepared, but quite what preparation is depends entirely on the context. However, here is some general advice for seminars. Really do any specific preparation asked for. After all, it's only polite. Make a list of questions that you might expect the seminar to help you answer. Clear your mind of other distractions, like when to do the shopping or who to text later. Be rested and well-fed. At the seminar, don't try to impress, just act normal. And of course, listen closely and carefully to everyone else. Okay, half a dozen tips, but if you only followed 2 for some reason, which would you say they should be? Honing your listening skills. In a lecture or formal talk, listening is difficult. How do you avoid dozing off? Does taking notes count as active listening if you aren't really following the thread? Well, maybe. The thing about lectures is that very, very little of what's said goes into your memory. Research suggests certainly less than 20%, and maybe more like 5%. And even that is garbled. I don't want to scare you, but if this chapter were a lecture, all you might have gotten from it so far is about 80 words. In a lecture, all the rest is likely to have failed to register and floated away. Anyway, that was, as I say, so far. Now that you've been warned, you're really going to pay attention. Remember, listening skills aren't only about listening to formal talks. They're about listening to other people in a context where you can and should participate. A seminar isn't a sparring match, a debate in which one team wins, maybe with the teacher as referee. It's a cooperative venture in which discovering weaknesses in your argument is something to be grateful for. Learning with the help of other people. A Russian psychologist called Lev Vygotsky has had considerable influence on what is sometimes called socio-cultural theory, an approach that includes important insights into the dynamics of learning. Vygotsky says that social interaction and social context are essential for real learning. To understand why, think about the experiences of young children, even babies. For them, a world full of other people who interact with them is essential for their cognitive development. All the higher functions of the mind have their origins in actual relationships between individuals, says Vygotsky. The range of skills that anyone can develop with guidance or peer collaboration exceeds what can be attained alone. The ability to learn through personal efforts, coupled with demonstrations and immediate feedback, is characteristic of human intelligence. Vygotsky even says that intelligence is better measured not by seeing what they can do on their own, as in standard tests, but by seeing what they can do when working with a skilled guide. Sounds strange? But think of learning a foreign language. How much can you learn by teach-yourself methods, as opposed to lessons from a native speaker while living in the relevant country and surrounded by a rich linguistic background? The broader and richer the language experience offered, the more someone is likely to learn, and the same is true for other subjects too. That's why listening skills come into their own during seminars, where, unlike with most formal lectures, you're allowed to talk. In a successful seminar, everyone listens closely, responds thoughtfully, clarifies statements, and justifies their thinking. In a formal lecture, you can't keep butting in with questions, but you can ask them just the same, privately, to yourself. You can jot down questions as they occur to you, and also answer them as a scribbled note, either positively, if the conclusion later seems to meet the point and satisfy your doubt, or negatively, if you think you begin to see a weakness in the position being presented. Either way, you become more active in the otherwise rather passive lecture process. The ultimate value of seminars is to wean people off that comforting habit of relying on authority figures any time something complex or unexpected comes up, and instead to try to work out their own strategies and answers, harnessing the power of group interaction. This is the best preparation for the complex and unanticipated problems that people, students, employees, all face in real life. Step 1 to being able to transfer your skills to real life is to be an active listener. Transferring skills to real-life problems. Much of education is about preparing for what comes next after education. It's about the extent to which what you learn can be applied, transferred later. Laszlo Bock, a high-up at Google, has some interesting insights on the importance of transferable skills. One of the things we've seen from all our data crunching is that GPAs, grade point average, are worthless as a criteria for hiring, and test scores are worthless. No correlation at all except for brand new college grads, where there's a slight correlation. Google famously used to ask everyone for a transcript and GPAs and test scores, but we don't anymore, unless you're just a few years out of school. We found that they don't predict anything. Laszlo Bock quoted in Headhunting, "Big data may not be such a big deal." Adam Bryant, New York Times, June 19, 2013. Yes, he really does say a criteria rather than a criterion, but you should forgive him because this is good news for people who hate having to work out which funny diagram doesn't belong in a group of funny diagrams, or pointless math puzzles. You can't see, but my hand's in the air. Here's Laszlo again. On the hiring side, we found that brain teasers are a complete waste of time. How many golf balls can you fit into an airplane? How many gas stations in Manhattan? A complete waste of time. They don't predict anything. Laszlo Bock, quoted in Headhunting, "Big data may not be such a big deal." Adam Bryant, New York Times, June 19, 2013. Remember, Google found that what did seem to matter was how people had dealt with open-ended issues in the past. Those who'd succeeded then were the ones who did best in the future, too. When you ask somebody to speak to their own experience, and you drill into that, you get two kinds of information. One is you get to see how they actually interacted in a real-world situation, and the valuable meta-information you get about the candidate is a sense of what they consider to be difficult. Laszlo Bock, quoted in Headhunting, "Big data may not be such a big deal." Adam Bryant, New York Times, June 19, 2013. Students, people in general, really, need less drill and practice and more opportunities to discuss things in an open-ended way, as well as opportunities to practice and apply ideas on real problems. Whenever you can, try to opt for projects at school, college, or in the workplace that involve problem solving. And if nothing on offer seems to do this, try to create within the project an element in which you can develop your critical thinking skills. It can only make your work on the project better. Every time you successfully tackle a project or resolve a problem, or, just as usefully, learn from an unsuccessful attempt, record it in a special place. Maybe your personal CritThink notebook. Get those highlighters out. Transferable skills. A number of studies have been conducted into what employers look for in graduates. The results suggest that the specific facts and skills explicitly taught in degree courses are relevant to only about 50% of vacancies, and in most cases, graduate recruits require further training. The qualities most sought after are general intellectual and personal skills, which receive relatively little attention in most degree courses. The idea that there are general skills that can be acquired, and that learning them in one context is transferable to a different context, runs contrary to much educational thinking of the recent past, which has instead tended to break everything down into different areas that are artificially separated one from the other. The current head of Google, Pichai Sundararajan, for example, is not a computer whiz kid at all, but a materials engineer. That's a branch of engineering that is highly interdisciplinary. Fun fact, when he went for his job interview at Google, it was on April Fool's Day, and on being asked what he thought of the company offering a free email service, Gmail, he treated it as one of the company's famous pranks. The grim faces told him it wasn't. The distinction between thinking and personal skills is far from sharp, because many things that are usually counted as the latter, as personal skills, are necessary if the intellectual skills are to be used effectively. For example, you often have to be able to be patient and persevering to make sense of new information. You have to be open-minded and tolerant of different options before you can evaluate and analyze them accurately. Similarly, it doesn't really matter how brainy you are if you can't communicate your insights and knowledge, as an exercise in public speaking makes clear very quickly. Noting a few notes. More is not always better. I hope that anyone planning to do some critical thinking would immediately see that taking literal notes during a lecture or maybe a class is a pretty silly idea. For tips on taking notes when reading, which is a very different matter, see Chapter 9. The obvious thing is for the lecturer or teacher to prepare the key points in advance, maybe in note form, and hand them out. Simple. So how come in some colleges you often find hundreds of students sitting in a hall scratching out identical notes while a professor recycles the core curriculum for the umpteenth time? One claim often made for this tradition is that note-taking helps people to memorize information, because maybe handwriting uses a different part of the brain than that involved in listening. But if you think about it, this is a pretty feeble justification. Technical stuff. In fact, the real explanation has much more to do with a tension between two very different approaches than teaching and learning, which can be categorized by recalling the differences between two ancient Greek philosophers. Socrates favored an interactive debating style in which he engaged people in conversation. Plato advocated a lecture-based approach to learning. Engaging in debate, the Socratic approach. Socrates' educational ideas drew upon the practice of the sophists, who were an early kind of thinking skills experts offering advice to the aspirational classes for a small fee. Their main role was to show private citizens how to win arguments in the public assembly, where all the decisions of the day were decided by a kind of mass vote, whether as politicians or as lawyers. The Socratic technique was, naturally enough, to engage people in debate, a process he often categorized using military or sporting analogies. The idea is that people learn best how to win arguments by trying to win arguments with a master. When eventually they can hold their own, they've been trained. The ancients saw reading and writing as secondary activities that weren't much use for honing these argumentative skills or for improving the reasoning that makes arguments persuasive. Tip. For Socrates, The very idea of taking notes would be anathema, and hence a no-go area, because it represents a passive kind of activity. Dialogue, not monologue. In both education and in social life, the traditional pattern has been long on monologues and short on dialogues. Teachers in particular saw themselves as experts whose task was to deliver chunks of information to students, ideally wedging it firmly into their permanent memory stores too. The strategies for doing this were that one person speaks, maybe reading out from notes or printed materials, while a group listens and makes notes. This is not an environment in which critical thinking flourishes. Instead, there should be dialogues and debates, and where really new content is being delivered, it should be done so more like a performance, with students as critical audiences. Listening to an expert, the academic approach. The academic approach is named after the first university founded by Plato. In his academy, the style of teaching was quite different from that favored by Socrates. The primary means of instruction was the lecture, a one-sided affair in which professors verbally delivered elements of their expert knowledge to an entirely passive audience. No surprise, then, that whereas Socrates seems never to have written any books, both Plato and his pupil, Aristotle, left behind comprehensive libraries of their ideas and research. Remember, when comparing Plato with Socrates, however, bear in mind this important qualification. Many of Plato's books are written in dialogue form. They purport to be recordings of little debates, starring Socrates, so that even if readers are passive in the sense of reading someone else's thoughts, they're active in that the dialogue constantly swings from one position to another and obliges them in turn to reflect constantly on their own views and positions. So, both Plato and Socrates actually agree on learning needing to be active rather than passive, even if Plato is heavily into delivering expert opinions too, after everyone's said their piece. Plato's dialogues are actually a radical kind of note-taking in themselves. The short plays are Plato's way of recording facts and views about his favorite great philosophers, with his personal insights added in. Comparing the consequences for the note-taking process. Plato lived nearly 2,500 years ago, but his ideas have had a huge influence over the form education and learning have taken in universities and colleges ever since. Take a look at the nearby sidebar, Socrates and Plato Go to School. As a result, in modern universities, students sit quietly through lectures or read assigned texts, books or handouts, in order to reduce them to notes. Later, they write essays. As you can see, Plato's academic approach has won an almost total victory over that of his guru, Socrates. To see what I mean, distinguish between two kinds of activity when taking notes. One records what the speaker is saying, and the other expresses your own views and responses. Often, note-taking in an academic context consists only of the first kind. After all, keeping up with all the information being delivered is hard. Socrates and Plato Go to School. For hundreds of years, in medieval colleges, learning was a mixture of Plato's kind of professional lectures, complemented by more Socratic meetings with junior teachers in which ideas were vigorously debated. The assumption in the lectures was, and continues to be, that disagreement is inappropriate. Until relatively recently, books were very expensive to produce, and so the lecture was a reasonable tool for the delivery of information. Yet nowadays, when not only books but also electronic tools have revolutionized the sharing of facts and ideas, the lecture is anything but efficient in terms of its original purpose. It has become an anachronism, along with exams that require the regurgitation of previously memorized facts. But anachronisms, persons or things that seem to belong to the past and not fit in the present, have always found a home in educational institutions. But in real-life situations where taking notes is a useful skill, perhaps during a meeting where new ideas are being generated, or previously unappreciated differences of opinion, perspective, clarified, notes are definitely going to be a mix of fact and interpretation. Plus, these days, unlike in the days of the ancient Greeks, people have access to all the background facts, often very speedily, too, via the Internet. For more locally specific information, the lecturer really ought to copy and hand out the data. Either way, time spent by an audience recording, say, grape yields in Aquitaine, France, 1960 through 1969, or titles of pop songs with numbers in them, is wasted time. Tip. So what does the smart note-taker put down? Perhaps very little. If the subject was those grape crops in Aquitaine, maybe the point the lecturer is making is that the yields have changed as small family vineyards gave way to larger businesses. If so, that's the kind of insight to note. You can also think of some possible objections to the theory. Make a quick note of that idea, too. Insights disappear fast unless jotted down. Smart note-taking, as opposed to the desperate and sometimes obligatory scramble to get everything down before the page changes, when a teacher lacking critical thinking skills is in charge, is all about selection, and selection is all about making judgments. Guess what? In many contexts, the decision about what's worth noting, or the reformulation of what's said, is highly subjective and very political. Democratizing the learning environment. Bias often operates in business meetings and in organizational structures, and can easily result in good ideas being lost. Awareness of and paying attention to the risk of all kinds of cognitive biases or dodgy mental shortcuts in meetings where decisions get made is a pretty valuable critical thinking skill. Tip. Here are some strategies for those in charge to avoid turning the audience into passive zombies taking notes, but not actually thinking or learning much. Create the right atmosphere. How many times do meetings reach bad decisions because participants are unable or too fearful to contribute? Fear stalks the classroom much as it does the boardroom. Where a hierarchy exists, people such as teachers or CEOs can make an important contribution by demonstrating their willingness to be found wrong and to change their views on matters. The level of a discussion is raised by the participants' courage to express their convictions, no matter how unusual they may be. Think about rearranging the furniture. Linked to creating the right atmosphere are decisions about the physical layout of a room or lecture hall. Rows mean most of the audience goes to sleep and would struggle to join in any discussion, whereas circles, in the style of King Arthur's famous round table, or a U-shape or horseshoe arrangement, encourage discussion. Ensure a mix of views. In areas where controversy is part of the game, have 2 or 3 different sets of facts, different proposals, different expert witnesses. But this also means a mix of roles, of personality types, including some cautious people alongside some enthusiasts and definitely some outside-the-box thinkers, the people who tend to disagree with the majority. They may not be right, but they ensure that the meeting hears a wider range of views. If you can't see anyone obviously like this, give someone the role and make it their job. Prepare the key facts and background. In a college context, this means homework. In a business context, it means due diligence, preparing briefing notes, PowerPoints, and background papers for all the participants to have and refer to. Most real-life decisions are based at some point on reference to factual data, and it makes sense to ensure that this material is as accurate, up-to-date, and complete as possible. Get everyone involved. At the outset, ask everyone to write down their initial positions, or maybe use a whiteboard to ask everyone for their balance sheets of pros and cons. This process increases the likelihood that people actually consider changing their positions later. Seminar skills. Critical thinking encourages the development of the whole range of skills, from the intellectual ones, like logical reasoning at one end, to interpersonal ones like the ability to work in teams at the other. There are communication skills, which are things like being clear and relevant in your contributions, and to the point and succinct, too. There are comprehension skills, which are things like the ability to see the core ideas in difficult and complex texts, and in rambling and disjointed presentations, too. Comprehension skills start with listening to what others say, and being open to different points of view. There are contextualization skills, which concern your depth and breadth of view. Can you see beyond traditional subject boundaries? Can you remain objective? And can you sometimes, when necessary, return to first principles? Can you see ahead to practical applications and make new connections? Linked to this is the skill of originality, which emphasizes independence of thought, flexibility of approach, and inventiveness. Originality shows itself in the ability to come up with new and stimulating examples and counter-examples. Then, there are the reflexivity skills, which are skills needed to reflect on your own thinking. How well are you communicating and expressing yourself? How are your ideas being received? Finally, there is the skill of cooperativeness. This is essentially the ability to work with others, whether as the leader or as one of the minions, either role benefiting from openness to discussion and new ideas. Doodling to generate creativity. What did Einstein, Thomas Edison, and Marie Curie have in common? Yes, they were all scientists, but the answer I'm looking for is that they were all inveterate doodlers. Anyway, that's the claim of people like Suni Brown, who has popularized the doodle in some best-selling books. In fact, she's a visual thinking skills expert who runs workshops for businesses such as banks, retailers, and television networks. What she says to the executives is that doodling boosts comprehension and recall, allows you to organize information in novel ways with increased clarity, doesn't require any skill at drawing. And yes, those little For Dummies icons are more than text decorations. Storyboarding, which is high-end doodling, is also a powerful tool, which television and media industry experts often use to illustrate ideas and concepts. Alfred Hitchcock planned out his horror movies in detail through storyboards. But the technique also aids businesses to prototype ideas. To be honest, doodling does require some drawing skills, and that's why most people give it up, along with being told off repeatedly by teachers, of course. For most teachers, doodling is associated with not concentrating, and that's the mark of a loafer, not an innovator. But even teachers can't know everything. Recent research into doodling suggests that when students shift their focus from interpreting other people's diagrams or charts to creating their own, they end up with a greatly enhanced understanding of whatever they're studying. The doodling students generate new inferences and refine their reasoning without even noticing it. And that's the key thing about doodling. It uses parts of the brain that you're not actually aware of. In fact, the word doodle means scribble absent-mindedly, which sounds bad, until you appreciate how incredibly subtle the mind is. Language taps only a tiny proportion of the power of the human mind, and doodling can draw on some of the rest. That's why some researchers think that doodling should be recognized as a key element in education, up there in value with reading, writing, and arithmetic, not to forget joining in group discussions. So, just for fun, grab a pen, use the margin of this book, and doodle about something to do with thinking skills. It could be the value of doodling. Don't worry, pretty much anything goes. The point is to pluck something from the swirl of ideas in your head and make it appear on paper. Answers to Chapter 11's exercises. The Great Intro. Of course, there's no one answer to this, but here are some general points that may be of help to you in deciding how promising your idea really is. Start with a personal story. Yes, these can be powerful and grab attention. Sad but true, a horror story about a bad presentation probably gets the most interest. Joke. In fact, a horror story about a bad presentation is a kind of joke, but be careful with this approach. As every stand-up knows, being halfway through a joke that your audience finds unfunny is an uncomfortable place to be. Ask a question. Well, this is a pretty direct way to engage with an audience. You might say, for example, how many people here have ever given a really lousy presentation? Questions like this might at least grab attention. However, you need a good follow-up. This would be back to telling a story. The kind of question to avoid is the boring one. It's incredible how often the same question comes up over and over again. So don't start by asking, how many of you have had experience at giving a presentation? Part 4. Reason and Argument. In this part, unlocking the logic of real arguments. Behaving like a rational animal. Using words to persuade. Presenting evidence and justifying opinions. Chapter 12. Unlocking the Logic of Real Arguments. In this chapter, picking out the key elements in everyday arguments. Examining reasoning in detail. Thinking about your listeners or readers. Arguments lie at the heart of critical thinking. "Oh, no, they don't," you cry. "Oh, yes, they do," I reply. That's not an argument, by the way, just irritating contradiction. Such arguments come in all sorts, hidden, irrational, polemical, or whatever. But a difference exists between the real-life, informal arguments of everyday life, ones about real issues addressed to real people, as opposed to the neatly organized formal ones you often find presented in philosophy textbooks. You encounter these real arguments every day. On TV, politicians argue about policies. Talent show judges argue about talent. And two-dimensional characters argue in soap operas. People argue about the relevant merits of their favorite sports teams or about whose partner at home is just the worst. Often these everyday exchanges aren't arguments in the philosophical or logical sense. They're more like disagreements and increasingly forceful statements of entrenched opinion. In this chapter, I examine some short but fairly typical real arguments, both to see how they're constructed and so that you can practice your key critical thinking skills. In the process, I take a look at aspects that people take for granted in everyday life, such as notions of cause and effect, and the different kinds of reasons, necessary and unnecessary, sufficient and insufficient, that people often confuse when trying to back up their conclusions. Introducing real-life arguments. In philosophy textbooks, the books on which most critical thinking guides are based, the arguments are usually tidy and precise, especially so-called deductive ones, the kind in which Sherlock Holmes specializes. The facts of the matter are clearly stated, and the conclusion is neatly marked out with a line or the word therefore. The focus of attention is definitely all on the logic, or lack of it. Remember, but in real, everyday life, people don't argue like that. They rarely start by stating their factual assumptions, but instead tend to leap instantly to the conclusion without any reasoning added at the end, or left to be guessed at. The evidence doesn't so much lead to the conclusion as the conclusion creates justifications for itself. Here are two examples. We must take urgent steps to reduce carbon emissions, or the world will overheat. Or, don't eat candy between meals, it's bad for your teeth. In addition, to confuse matters further, in everyday language people use the word argument to mean a bad-tempered quarrel or dispute, which is the last place to look for logic or structure. Even so, you can still restate much of this type of emotional outburst philosophically. After all, most everyday disagreements start with a fact or claim. The argument then works backward by offering reasons why the statement is true or false, depending on the point of view of the speaker. In this section, I describe informal logic, the particular role of premises in arguments, and how images can also be used to back up claims. I also investigate the logical structure of arguments, revealing one common error that many people, even professors, often make. Coming as you are. Informal logic. Informal logic sounds intimidating, but needn't be at all. Informal logic. This is all about assessing and analyzing real-life arguments and debates using everyday language. The work is really in the conversion of issues expressed in informal, everyday language into something more structured. Formal logic. By contrast, formal logic is not concerned about particular issues or about the world. Often these arguments use symbols and letters to represent the argument. Once an argument has been reduced to symbolic notation, its structure should be easier to see, and logicians can then manipulate it in the same sort of very precise way that mathematicians produce geometrical proofs or even manipulate equations. I know explanations can get more confusing when additional explanations are added into the explanation. Informal logic is really the topic. Formal logic just crept in. Logic, science, and everyday reasoning. People expect scientists to be good role models of crisp, clear thinking. But, as I discuss in Chapter 2, scientific thinking and logic are two quite different things. Science is based on the principle of drawing general, universal conclusions from a limited number of cases. For example, if you catch a cold after being in a train with someone sneezing all the way, you conclude that the sneezing near you gave you germs. It's a powerful method, but strictly speaking, illogical. Maybe you got the cold waiting for the train. Logicians define this kind of reasoning, which they call induction, as invalid reasoning, and only see deductive reasoning, Sherlock Holmes's kind, as valid. The problem with deduction is that it doesn't provide any new information, it can't. So in the real world, a lot of arguments are, strictly speaking, invalid. Tip: how formal should you be when setting out your position, though? Well, it's a little like choosing formal or informal clothes. You dress formally for an interview and informally to cut the grass. To illustrate, I need an everyday argument. Sure enough, here comes one now. You're a rotten husband. You don't do the dishes, and you don't even do the gardening. In philosophy, arguments are typically presented as a series of statements that are themselves true or false. These are generally called premises, coupled with a conclusion. Thus, the critical thinker prefers to restate the previous conversation with the following structure. First premise: rotten husbands are men who don't do the dishes and don't even do the gardening. Second premise: you don't do the dishes and you don't do the gardening. Conclusion: you're a rotten husband. As I explain in more detail in Chapter 13, if the argument is valid, constructed correctly, then as long as the premises are true, the conclusion must be true too. This argument, by the way, isn't valid. Hint: rotten husbands aren't the only people who don't do the dishes and don't do the gardening. Grandpa doesn't either. But pointing out the error in the reasoning is hardly going to let anyone avoid doing their chores, which just underlines that getting the logical structure of an argument right isn't going to settle many real-life issues. But even so, it can help identify the real issues in a debate. Tip: try to keep the two notions of truth and validity separate, because you really need both. Remember that a valid argument is one in which you can be sure that the conclusion is true if the starting assumptions are too. This is what makes valid arguments a pretty powerful reasoning tool, if you think about it. An invalid argument gives no such reassurance. Remember, circular reasoning. Here's an example of circular thinking by the German statistician Ernst Engel, who carried out much praised research into the relationship between spending patterns and income in the 19th century. Engel's law states, the poorer the individual, the family, or a people, the greater must be the percentage of the income needed for the maintenance of physical sustenance, and of this a greater proportion must be allowed for food. Unfortunately, as Ian Hacking points out in his book The Taming of Chance, treating this as a firm law is pushing things, because Engel had started off by taking the proportion of outgoings on food as the measure of material standard of living. That is, his law simply says, the more of your money you spend on food, the poorer you are. The poorer you are, the more of your money you need to spend on food. It's pretty circular. On the other hand, the reasoning seems to be valid. Circular reasoning should be, because the conclusion is only restating the assumption. Philosophical arguments are either valid or invalid. They aren't true or false, for that matter. Only the premises and the conclusion, which are factual claims about the world, can be true or false. Confusingly, perhaps, a philosophical argument can be valid even if its premises are false. Philosophers call such arguments valid but unsound. Informal, everyday arguments tend to mix up premises and conclusions, and often in the process the distinction between true facts based on evidence and not necessarily true opinions, conclusions, based on reasoning, gets lost. Remember, in written arguments, anyway, words such as because, if, or since, and phrases such as if you really think that such and everyone knows that such and such, often point at the starting assumptions. while words such as then and therefore flag up a conclusion. I say more about these sorts of textual clues and details in Chapter 10. But the problem with real arguments is that they come in every possible shape and size. Much of the reasoning isn't even spoken or written down. You have to guess or decode what's going on before you can judge whether the reasons support the conclusion, which is what arguing is all about. Persuading with premises. Informal arguments that use everyday language should still set out an argument in good persuasive steps, putting the assumptions, the premises, first, and making sure that the real point is a deduction that follows on, or at least appears to, later. Here's a pretty good example of how to do it from logician and political activist Bertrand Russell. He's putting forward a deceptively simple argument concerning educational policy. The evils of the world are due to moral defects, quite as much as to lack of intelligence. But the human race has not hitherto discovered any method of eradicating moral defects. Intelligence, on the contrary, is easily improved by methods known to every competent educator. Therefore, until some method of teaching virtue has been discovered, progress will have to be sought by improvement of intelligence rather than of morals. Bertrand Russell, Skeptical Essays, 1935. Grab a pen and paper, or cool dudes, take notes on your phone, and set out Russell's argument as 3 pithy, short sentences, split into 2 claimed sentences of fact and a conclusion that's supposed to follow from them. Pop to the end of the chapter to see my take, but no peeking before trying to see the structure yourself. Prisoner Russell. The 20th century philosopher Bertrand Russell often argued against the views of the government of the day, and its response was, surprise, surprise, not to fight him by pointing out logical errors in his political positions, but with the law courts and the police. He was imprisoned several times for catch-all offenses like unlawful public assembly or disturbing the peace while campaigning on issues like nuclear disarmament and votes for women. Too often, in real arguments, logic is often the last thing that decides the issue. Using pictures in everyday arguments. Real arguments don't depend just on words, of course. The most successful political broadcasts, for example, mix a voiceover with compelling images to persuade their audiences. A picture really is worth 1,000 words. Homeowners are supposed to be able to persuade potential buyers by brewing coffee or setting out a plate of fresh-baked cookies. In this section, I discuss how these illogical elements persuade, showing that the process is often very subtle. Tip: with real arguments, the addition of visuals, whether pictures, diagrams, or charts, can certainly make claims more persuasive. But whether visuals can make a logical difference, as opposed to reinforcing the emotional rhetorical strength of an argument, is less clear. Some people are skeptical that images can do any work other than rhetorical. Others think that images can carry arguments independently. Still others believe that images can carry at least some parts of some arguments. Many advertisements rely on pictures to support an argument. Imagine an advertisement for, say, Dummies Jeans that says simply, "Buy Dummies Jeans." It wouldn't sell very many just with that, but coupled with a picture of some attractive, successful, fun-looking young couple, it very well might. The reason is the implied connection between being attractive, successful, fun-looking, and young, and the jeans. If you buy Dummies Jeans, then you'll become like these people. Or, take the classic advertisement from the 1920s in Figure 12-1, which simply makes an assertion about the brand of coffee that's worth paying a little more for. The evidence for the statement is in the pictures. The man is obviously drinking it with enjoyment, while the shadowy drinker just behind him is obviously not getting the same satisfaction from his cup of joe. Have a go at expressing the coffee advertisement as a simple, logical argument. Jot something down before reading on. Okay, this is how I deconstructed the ad. First premise: paying a little more for something is worth it if it brings you real satisfaction. Second premise: this kind of coffee brings you real satisfaction. Conclusion: therefore, paying a little more for this kind of coffee is worthwhile. That's the surface message anyway. The subliminal, hidden message is that the particular brand of coffee is superior to other brands. This message appears in the argument as one of the assumptions in the premises. Checking a real argument's structure. Even though real arguments are phrased in ordinary language, they still have a structure that you can try to reveal by stripping away the unnecessary details and expressing the whole thing in its argumentative essence. Sometimes the use of everyday language itself causes problems with the argument's logic. One logical error is so common that it has its own special name: the fallacy of affirming the consequent. You don't need to know the name, but you do need to be able to spot this mistake in reasoning, because it's probably one of the most common errors people, even famous philosophers, make. The fallacy of affirming the consequent involves arguing that one event was caused by another merely because it occurred after that event. It's also called making a logic reversal. People who affirm the consequent imagine that the effect of a cause is also the cause of the cause. But no, of course not. Analyzing an example of a real argument. Here's a slightly dodgy real argument that illustrates the point from a recent book, The God Argument, by A.C. Grayling, a university philosophy professor. Socrates debates the limited value of pictures. Most people think that pictures or TV clips are a rather poor way to argue, because they can be misleading, manipulative, and of course manipulated. Written materials, on the other hand, are often considered to be straightforward, serious, and honest. But the ancient Greek philosopher Socrates thought that written words also play tricks, and so real debates had to be live, so that everything and anything could be immediately challenged and tested. In one of Plato's little plays featuring Socrates and someone else buttonholed into having the debate, Socrates tries to persuade Phaedrus, author of a book of fables, that not only pictures but also words themselves, when written down, are limited and inferior compared to real verbal exchanges. You know, Phaedrus, that is the strange thing about writing, which makes it truly correspond to painting. The painter's products stand before us as though they were alive, but if you question them, they maintain a most majestic silence. The same goes for written words. They seem to talk to you as if they were intelligent, but if you ask them anything about what they say, from a desire to be instructed, they go on telling you just the same thing forever. As presented in his book, Religion is a Nasty Business, consisting of hanging homosexuals, beheading or stoning to death adulterous women, and subordinating women and children in Bible Belt America. Because religious belief, historically and today, leads to these awful things, says the author, people should always try to discourage religious belief. This is a real argument in two senses. People really make it, the professor does in his book, although not in so many words, and it's expressed in everyday language. Here's one way of looking at its structure, including the evidence offered. First premise. Religious belief leads people to do terrible things to other people, such as hanging them for being homosexual or stoning them to death. Second premise. Leading people to do terrible things to others, such as hanging them for being homosexual or stoning them to death, is bad. Conclusion. Therefore, religious belief is bad. Remember, premises don't have to be true, and you don't need to prove them. They come with an implied if before them, and the conclusion is only supposed to be true if the premises are. On that basis, the claims here look okay. To investigate whether the sweeping conclusion demands acceptance too, as the professor hopes, you can structure the argument a bit more formally as follows. First premise. Religion leads to terrible things. Second premise. If something is terrible, it should be banned. Conclusion. Therefore, religion should be banned. The structure looks to be something like this. If A, then B. If B, then C. Therefore, if A, then C. Expressed in this way, the argument certainly appears to be valid, in the sense I describe in the earlier section, coming as you are, informal logic. But in fact, a bit of cheating is going on. It lies in the words of the original argument. Check out the first premise again, the one that says, religious belief leads people to do terrible things to other people, like hanging them for being homosexual or stoning them to death. The professor doesn't flatly say that religious belief always and invariably leads to each of its adherents doing terrible things, but only that it sometimes leads to some people doing them. Clearly, he can't state the former because Mother Teresa, for example, didn't stone adulterers to death in India but helped sick children. So, a more accurate way to represent the argument might be as follows. If A, then sometimes B. If B, then C. Therefore, if A, then C. However, this argument is certainly not valid. As long as some A aren't B, any additional information, no matter how juicy about B, is always going to be entirely irrelevant to them. On the other hand, maybe the professor isn't intending to argue this. Perhaps the essence is instead better summarized as follows. First premise. If religion is an evil influence on people, then people's minds will be addled and lots of bad things result. Second premise. People's minds have been addled and lots of bad things have resulted. Conclusion. Therefore, religion is an evil influence on people. Even if it is this version, though, the conclusion is still rather wonky. See the nearby sidebar, Scientists Arguing Illogically, for more on this. The problem now with this reasoning is that another explanation for the bad things may exist, such as inbred sexism or aggressive pursuit of economic self-interest. But such issues are getting into the area of sociology. Explaining the world's problems isn't your task here. You're just looking at the structure of arguments. And in this case, it does seem that the logic of this real argument is rather wonky. Discussing the usefulness of the fallacy. The fallacy of affirming the consequent is just one of a list of logical fallacies that Aristotle drew up thousands of years ago, but are still going strong. See Chapter 14 for details. Indeed, it's such a common argumentative tactic that pointing it out can seem a cool trick to make you look much cleverer than your opponent. But in real life, is it really an error at all? Scientists Arguing Illogically. You come across many famous historical examples of scientists committing the logical error of affirming the consequent. Take the grandest theory of them all, the Big Bang, which supposedly explains the origin of the entire universe as resulting from a primeval atom, well, exploding. It includes within it an expectation that the universe should be filled with leftover radiation distributed evenly. The argument goes as follows. First premise. If the universe started with a Big Bang, then there should be lots of stray background radiation left over for the radio telescopes to find. Second premise. Lots of stray background radiation is left over that the radio telescopes have found. Conclusion. Therefore, the universe started with a Big Bang. Naturally, when radiation was discovered, the Big Bang theory was counted as confirmed. Only now, rather grudgingly, are some scientists reopening the case, because although lots of this background radiation is indeed scattered around the night sky, it doesn't seem to fit the more precise requirements of the theory. For example, instead of being evenly spread around, it seems to be located in strange clumps. Applying full logical rigor to the real world is difficult. Perhaps the moral is this: don't throw out the useful science with the logical bathwater. People who commit a logic reversal and affirm the consequent are implying that the effect of a cause is also the cause of the cause. To see why this is wrong, recall, from the logic vaults, the crown jewel of the logic, the valid argument called the modus ponens, from the Latin for the way that affirms by affirming, which has a special form you can see in the following example. Suppose you're talking about Paris. A correct argument proceeds like this. If it's December, then it will be cold in the pavement cafes. It is December. Therefore, it will be cold in the pavement cafes. The conclusion is true because the premises are taken to be true. If A, then B. A. Therefore, B. But look at what happens if instead the argument is mangled to become B, therefore A. If it's December, then it will be cold in the pavement cafes. It is cold in the pavement cafes. Therefore, it must be December. But no, it can be a cold day in January or in almost any month. Remember, for logicians, this is definitely a silly mistake to make. But that's not quite the same thing as saying that it's wrong in everyday use and in real arguments, because the invalid argument is actually a way of offering evidence for a particular belief. Delving deeper into real arguments. Far better an approximate answer to the right question, which is often vague, than an exact answer to the wrong question. John Tukey. In real, everyday, informal arguments, if people don't agree on the underlying facts, the starting points, no amount of persuasion ever allows one side to persuade the other of the rightness of their position. In this section, I take a look at the classic if-then formula, revealing some aspects that people can mix up: cause and effect, unnecessary and insufficient conditions, and independent and joint reasons. Considering the formula, if A, then B. In a lively book called If A, Then B, How the World Discovered Logic, two philosophy professors, Michael Shenefeld and Heidi White, argue that reasoning, knowledge, and rationality are first and foremost matters of logic, of applying that deceptively simple formula, if A, then B, to the world. What's more, they argue that the history of the world is also the history of simple logical forms. For example, the simple arguments I discuss in this chapter where statements are presented and then claimed to lead to a certain conclusion, emerged out of the ancient Greek way of making decisions. For the background history, see the nearby sidebar, A History of Arguing. A History of Arguing. In ancient Greece, political issues were decided at public meetings in which the facts were represented and the citizens voted after drawing their conclusions. In this sense, the ancient Greeks invented not so much democracy, the rule of the people, but something much more useful: arguments. Of course, arguments lead to conflict, such as the long battle between Catholicism and Protestantism in medieval Europe. Although some historians disagree, Michael Shenefeld and Heidi White think that the conflict was about whose version of Christianity was theologically correct, and that this social debate made people especially concerned with problems of logic. Later, by encouraging people to refer to the Bible themselves, Martin Luther, for the Protestant side, encouraged people to examine the premises through personal reflection and individual reasoning, instead of just accepting the conclusions of others, notably the church authorities. As Shenefeld and White see it, logic didn't help sort out the war because the two sides started with different and conflicting premises, and so a great collision between Catholicism and Protestantism became inevitable. The idea is that if everyone agrees to be logical and let rules decide arguments, people should eventually reach decisions that everyone can see the reasons for and, by and large, can accept. Assuming a causal link. Causal links in nature are central to the way people make sense of the world. And just as in logic, they're often not thinking directly about the mechanisms, about why A leads to B. For example, consider these arguments or claims. Don't eat wild mushrooms. They're poisonous. If you study hard, you'll get a better grade in the exam. They are very different kinds of statements. One seems more causal than the other. Yet in another way they're both similar because they're both statements of the kind all A are B. All wild mushrooms are poisonous. All people who study hard get good grades. The 18th century philosopher David Hume is credited with a great insight into everyday arguments. He says that the deeply held belief of causal links, for example, that not watering plants causes them to wither, or that throwing rocks at windows causes them to break, isn't logical, but merely psychological. His rather abstract point about cause and effect has many practical implications for critical thinking because he's challenging the root of logic itself. David Hume says that the idea that one thing causes another is a human construction, based on past observations and experience. This is how he puts it. Surely, if there be any relation among objects which it imports to us to know perfectly, it is that of cause and effect. On this are founded all our reasonings concerning matter of fact or existence. Our thoughts and inquiries are therefore every moment employed about this relation. Yet so imperfect are the ideas which we form concerning it that it is impossible to give any just definition. In other words, a key idea that human beings use to make sense of the world around us, that what we have observed one day in one set of circumstances can be learned from and assumed to apply to another day in similar circumstances, is based itself just on faith. Why should the same cause always have the same effect? His idea is so radical that it makes nearly all arguments fall to pieces straight away. Hume admits himself that he can see no answers to his problem, but suggests shrugging and carrying on anyway. In a sense, that is what we have to do. But critical thinkers can benefit from the warning by being extra skeptical and asking questions when someone asserts that a certain outcome will always follow a certain action. Discussing unnecessary and insufficient conditions. Here's another way in which drilling down into logical reasoning and revealing their formal structures can help in even informal arguments, specifically the difference between necessary and unnecessary conditions. Everyone's familiar with the concept of something being necessary. For example, in order to keep fish in an aquarium alive, it is necessary to make sure that it's full of water. If you let the water evaporate, the fish perish. In the all-important if-then statements of reasoning, the second bit that follows the word then, technically known as the consequent, gives a necessary condition for the first part, which philosophers call the antecedent. If Phyllis the goldfish is to be happy and healthy, the antecedent, then water in the aquarium must be kept topped up, the consequent. So important are necessary conditions that in ordinary language people have many ways to express them. For example, water is necessary for fish to live. Fish must have water to live. Without water, fish die. No fish can survive long outside water. A condition X is said to be necessary for another condition Y if, and only if, the falsity, the non-achievement of Y, guarantees or brings about the falsity of X. But keeping the water level topped up isn't a sufficient condition for keeping Phyllis the fish happy and for having a successful aquarium. For example, you need to make sure that the water is clean, that oxygenating weeds are present, and that the water is the right temperature. So the water level is a necessary but insufficient condition. So far, so useless. But this insight does lead you towards being able to make a new suggestion. If Phyllis the goldfish is to be happy and healthy, then I must place a plastic castle at the bottom of the aquarium for her to swim around. Certainly, this is a very nice thought, and I'm not against it at all, but is it absolutely necessary to provide plastic castles for goldfish? Not at all. You could provide some interestingly shaped rocks instead, or maybe more weeds. So clearly this is an unnecessary condition, because Phyllis can be healthy even without the castle. But is the plastic castle also an insufficient condition? Yes, it is, because if you fail to feed her, or let the water level drop, or lots of other things, the plastic castle isn't enough to keep Phyllis healthy and happy. Condition A is said to be sufficient for a condition B if, and only if, the implementation of A guarantees the truth, the bringing about of B. If you like, before reading on, pause to make a list of necessary conditions for Phyllis the goldfish to be happy and healthy. Then take a look at my suggestions at the end of the chapter. But don't spend too long, because in real arguments, specifying either necessary or sufficient conditions is often impractical. Instead, a huge amount of shared assumptions are needed. Investigating independent and joint reasons. One quite subtle distinction in critical thinking is between independent and joint reasons. Many arguments work quite happily on just one reason. You can see these arguments as assertions. Killing animals is wrong. Therefore, everyone should become vegetarians. The argument works because the word wrong includes the assumption that we have to do whatever we can to avoid the bad thing happening. But it doesn't work if you think killing animals is sometimes not wrong, but natural. I get annoyed if my cat kills a songbird in the garden, but I accept it if a hawk does. In other words, like a lot of controversial matters, it comes down to ambiguity. Sometimes killing animals is wrong. The structure may be as follows. People who aren't vegetarians are involved in the killing of animals. Killing animals is always wrong. Therefore, everyone should become a vegetarian. In contrast, a joint reasoning argument is one in which you need at least two reasons in order to draw the conclusion, and you can't draw the conclusion from any one of the reasons on its own. Take a look at this one, with 4 reasons offered to support the eventual conclusion. 2/3 of the world's surface is covered by water. If people stop eating fish, then pressure on the fragile ecosystems on land will be increased. Increased pressure on the fragile ecosystems on land is bad for the environment. Vegetarianism requires people not to eat fish. Therefore, vegetarianism is bad for the environment. There. In this section, you've used logic to provide 2 opposite sides of the argument. Vegetarianism is morally right, and vegetarianism is morally wrong. That's a pretty handy critical thinking skill. Being aware of hidden assumptions. Looking at arguments from the point of view of those making them helps you to spot hidden assumptions that they're making, assumptions that you may want to discuss openly and perhaps challenge. Tip. Similarly, turning a critical eye on your own beliefs and values allows you to identify premises or beliefs that may not be accepted at face value by the people listening to or reading about your views. Elements that influence your views, often without you really realizing it, include the following: race, nationality, and culture, language and your education, family status. Maybe you have children who depend on you, or maybe you rely on some help yourself. Economic or social class, whether you're religious or non-religious. Views of your peer group. For example, teenagers are notoriously sensitive to and influenced by whatever their friends are doing. Remember, if you can identify the hidden assumptions in other people's positions or the problematic aspects of your own, you're better able to do 2 useful things. Anticipate the kind of counter-arguments that may be made. Make a kind of preemptive maneuver by rethinking and, where necessary, strengthening your own assumptions, especially ones you hadn't really been properly aware of. Answers to Chapter 12's exercises. Here are my answers to this chapter's tests. Persuading with premises. Here's my analysis of the argument's key premises. First premise. People's bad behavior should be improved either by improving their morals or through education. Second premise. There's no known way to improve people's morals. Conclusion. Therefore, people's bad behavior should be improved through education. Necessary conditions for goldfish. Here's a couple that you probably didn't think of. You mustn't have any cats that can gobble up Phyllis or any nasty anchorworm eggs introduced into the aquarium, say on the pondweed. Don't kick yourself if you missed those 2. Instead, award yourself 1 mark if you listed 10 points and 3 marks if you wrote less. A critical thinker soon realizes that it isn't too useful to spend too long on that list because it is potentially an infinite task. Chapter 13. Behaving like a rational animal. In this chapter, looking at the laws of logic, seeing successful arguments and finding fallacies, making valid points when debating. Stuart Umpleby, a social scientist and author of The Financial Crisis, How Social Scientists Need to Change Their Thinking, offers a cautionary note about the too literal, too narrow use of logical rules, a view that I take a closer look at in this chapter. I also look at how to use logic to strengthen your own arguments and help you spot weaknesses, or indeed strengths, in other people's. On the way, I emphasize that logic is a tool that suits only certain applications and isn't a universal shortcut to finding the truth. If you don't believe me and think that logic can settle everything, check out this chapter's discussion of the laws of thought. I also include an opportunity for you to hone your skills via a deceptively important little argument that highlights the role of link terms in producing a good, sound argument, and the danger of ambiguous language for producing a bad one. Setting out laws for thinking logically. The ancient Greeks provide many of the foundations for both logic and good, rigorous thinking in general. The first philosophers strove to eliminate ideas that seemed vague, contradictory, or ambiguous. And the best way to accomplish this, they thought, was to work out the rules of thinking that would reliably lead to clear and distinct ideas. In other words, to discover and then follow the laws of thought themselves. This chapter explains what those laws are, but it's also important to remember, and much less often actually done, that in spite of how dominant these ideas have been over the centuries in both science and philosophy, they have not been without their critics. And for every point in their favor, there are equally powerful arguments against them. That's what a critical thinker should expect, of course. The real issue seems to be not so much whether the principles are true or not, but where and when they are applicable. The laws of thought have an important role to play in critical thinking, but they are not the whole story by any means. But, having said that, Aristotle's ancient book on common logical errors, and also on sound ways of theorizing, is a great way to start thinking more precisely and methodically. His big idea is that an argument is valid when the conclusion follows logically from its starting assumptions, the premises, and he's not too bothered if a conclusion can still be complete nonsense if there's a problem with those assumptions. If you start with true, relevant, and non-contradictory assumptions and structure the argument correctly, then you have an ironclad guarantee that the conclusion is true. This is what is meant by a sound argument in this context. Asking Aristotle about reason. For the ancient philosophers, perhaps for most people today, a good argument was one that brought people to agree with the speaker, and it really didn't matter quite how that was achieved. It might be by careful use of rhetorical devices, such as making 3 points in sequence, or through ridiculing the opponent. For more on this, see Chapter 15. Or it might be by recalling the legends told about the gods of Mount Olympus. Probably the most influential philosopher of them all, Plato, used the whole range of persuasive techniques in his philosophical writings, which included a fairly detailed blueprint for running a small country, his famous playlet called The Republic. Ironically, I think it could have been a jealous reaction to Plato's literary and rhetorical skills that prompted his student Aristotle to look instead at the nuts and bolts of arguments and to try to tease out the elements of the most powerful ones. Whatever Aristotle's real motives, this was really innovative work, and it changed the way people thought and argued forever. Remember, neither Aristotle nor the other Greek philosophers made any distinction between scientific and philosophical investigations. For them, everything was philosophy. So what was a bad argument in politics was a bad argument in science, too, and vice versa. But as I will explain in this chapter, Different elements of an inquiry actually need different approaches. Experimental science, for example, often uses inductive reasoning, drawing general conclusions from limited evidence, a procedure that is by definition invalid. This is what the experimental method is all about. But scientists are often also philosophizing, presenting premises and claiming that certain conclusions follow, and these parts of their work need logic checking just as much as anyone else's. Aristotle came up with 3 mental rules that he called the laws of thought. Philosophers tend to understand these laws as part of an attempt to put everyday language on a logical footing, which, like many contemporary philosophers, Aristotle regarded as the key to human progress. Logic is all Greek to me. Aristotle, 384 through 322 BCE, is generally considered the father of logic, even though the Chinese got there before him and many other ancient philosophers had talked in detail about the issues. But Aristotle wrote the book, and so he gets the credit. Aristotle worked on every subject under the sun with alarming zeal, and was particularly interested in observing nature. But nothing interested him more than sorting out all the different kinds of reasoning that people use. Aristotle's way of approaching any question had a great influence on how other people did too, for centuries after, for better or, as it more often was, for worse. One of his dodgy ideas was that women are damaged men, another was that the earth is motionless, and a third one, still influential, is his view that every organism has its own particular function or place in nature, and that the particular role of humans is to reason. Abstract thinking is what people are better at than any other member of the animal kingdom. One problem with this idea is that it encouraged people to treat animals as unthinking objects. Another was that Aristotle insisted that women lacked the same ability here as men. Tip: don't make the mistake of thinking that Aristotle's laws of thought are just ancient history. They remain a pretty big deal. Some 2,000 years later, George Boole, whose logic is vital for today's software and computers, acknowledged Aristotle's influence and pioneering role, although he thought it was too simple and produced his own, alarmingly math-based one instead. Drum roll, please. And now, here are Aristotle's 3 laws of thought. The law of identity. Whatever is, is. The law of non-contradiction. Nothing can both be and not be. The law of excluded middle. Everything must either be or not be. Doesn't sound too difficult, does it? Well, read on. Posing problems for logic. Perhaps you're wondering what these 3 laws mean in practice and whether they stand up to critical thinking. Tip: well, for a start, avoiding contradiction isn't as easy as it sounds. Many of the fallacies in arguments come from asserting 2 contradictory things. Plus, many of the ambiguities and confusions that create unbridgeable differences of opinion can be traced back to a failure to apply the law of the excluded middle. Plato, who was Aristotle's mentor, was well aware of the laws of thought, but he was more interested in where they seemed to not apply. You see, in certain cases they lead to absurd conclusions. For example, in one of Plato's little plays, someone argues that Socrates must be the father of a dog, because the dog has a father, and Socrates admits that he's a father. The law of non-contradiction, nothing can both be and not be, says that one can't be both a father and not be a father at the same time, and so logic seems to require that Socrates must be the father of the dog. Of course, Socrates is obviously not the father of the dog, but the problem is seeing where the thinking has gone wrong. In other words, where and how to apply the laws raises as many questions as those the laws are supposed to settle. Warning: don't be so in awe of Aristotle that you rush to agree on all his thoughts. Critical thinkers should never rush to agree. In spite of how dominant his laws of thought have been, they have had their critics, and philosophers from Heraclitus to Hegel have leveled powerful arguments against them. On the basis of everyday experience, for example, Heraclitus argued that contradictions not only existed but were essential and the basis of a thing's identity. Writing much later, Hegel said the laws only applied to human-made abstractions, not to blurry reality. Hegel even attacks the law of identity, saying it is no more than a tautology that tells us almost nothing. He says that the way a thing truly takes on an identity is through what it is not. The fact is, Aristotle has his fair share of foolish views, such as the influential but false doctrine that bodies fall to earth at speeds relative to their mass, or the dreadful, but popular with men, claim that women not only don't but can't reason and are best seen as a kind of domestic animal. Yes, he really said that, even as his mentor Plato was writing the opposite and counting women as great philosophers. Be aware, though, that for traditional logicians, guardians in their own mind at least of sound reasoning, the laws of thought are the foundation of the whole of logic, with all other principles of logic mere elaborations of them. So critical thinkers break the laws at their own risk. Is logic a boy thing? Many people think that logic is something that suits males better than females. In popular language, the term female logic is derogatory. However, the research evidence is quite clear that in almost all the thinking skills, word skills, analogy making, intuitive thinking, method and organization, very little difference exists in the ways that men and women think. And if any difference does exist, education, by which I mean things like reading this book, can easily compensate. Take heart from the American logician Christine Ladd Franklin, who became the first woman to receive a Ph.D. in mathematics and logic in 1929 at age 78. Mind you, this was 44 years after she had earned it, and the delay was due entirely to sexism. At the time, women were not allowed to graduate from the university where she studied, no matter how good their work. Nonetheless, some research does show a gender gap in formal logic and math. Formal logic, the kind expressed using symbols rather than in words, is a kind of math, not a part of philosophy, although it is crept in there, claiming, for example, to be a good way to look at arguments. Likewise, tests that ask students to rotate shapes and so on also seem to favor boys at the expense of girls. It seems that these tests involve abstract logical manipulations that at some level call on the same mental architecture and use of the same processing elements of the brain. 4 points are worth making about the issue. Expectations have a very clear influence on outcomes. A 1999 experiment, led by Stephen Spencer, a Canadian psychologist, found that girls performed significantly better in a logic test when no seeds of doubt were planted in their minds beforehand. This is what social scientists call the problem of the stereotype threat. The boy-girl differences are much less than the variation within gender. Curiously, too, left-handed boys are worse at the male logic and spatial awareness tests than right-handed boys, but left-handed girls are better at them. The bottom line is that it's not clear that males have any advantage in informal logic, which is what critical thinking is about. Seeing how people use logic. In this section, I look at some of the key logical structures that people use, for better or worse. Identifying convincing arguments. What makes an argument convincing? The evidence advanced for a position being correct isn't enough. You also need some reason to accept that the conclusion follows from the evidence. Accepting that true premises don't make for true conclusions. Remember, in logic, true premises, all the assumptions an argument starts out by simply asserting are true, don't ensure that a conclusion is true. They only do so if the reasoning used, the argument, is valid, which in this context means structured correctly, respecting things like the laws of thought described in the previous section. Tip: the easiest way to prove your point is to structure it as a hypothetical, an if one thing, then another thing, followed by a demonstration that the first thing really is the case. This kind of argument is called affirming the antecedent. The antecedent is the thing that comes before. Philosophers often express arguments in symbols, whereas critical thinkers use ordinary English. But noting that the validity of arguments is most easily tested using symbols helps you to remember two important things. Making your argument valid means logic checking its structure. Starting off with false premises, assumptions, doesn't actually make the argument invalid, but it does make it unsound and unpersuasive. Here's this affirming the antecedent argument in symbolic form. If P, then Q. P, therefore Q. And here's an example. If there is evidence of design in the universe, then there must be a designer. There is evidence of design in the universe. Therefore, there must be a designer. Goodness, does that settle the huge old debate simply through logic? Not really. You can still disagree over whether the premises are true. What's meant exactly by a designer, or indeed one with a capital D? Unless the starting assumptions are true, the structure of the argument can be as excellent as you like, but you still can't be sure of the conclusion. Another way of making this point is to say that a valid argument is truth-preserving, in the sense that if you put true premises in, a true conclusion comes out the other end, but not the other way around, mind you. If the premises are false, you can't assume that the conclusion is false too. A politician can still be right, after all, despite having all their facts and arguments wrong. Aristotle came up with 256 variations of arguments that have two assumptions followed by one conclusion, of which he thought 19 were truth-preserving. The rest were fallacies, and hence ones to avoid, most obviously so. Actually, people think nowadays that at least 4 more of his 19 safe forms are dodgy, showing just how difficult being fully logical and rigorous is. But that doesn't mean you shouldn't try. Denying the consequent. A really useful and logically valid form of argument is denying the consequent, modus tollens in Latin. As the name rather gives away, instead of proving that the if bit is true, you prove that the then bit, the consequent, is false. For example, an argument like this: if I eat lots of candy, then my teeth will fall out. My teeth have not fallen out, therefore I have not eaten lots of candy. Tip: denying the consequent is a great argument form to use, simple and effective. However, as the example hints, it proves no more than what the first premise asserts. In other words, if the premise isn't actually true because, for example, the candy lover brushes their teeth very thoroughly each night, then the fact that the argument form is valid doesn't save it from being unsound. Check out my explanation of this important concept in the earlier section, Setting Out Laws for Thinking Logically. Remember, check your facts, because untrue premises lead nowhere. Falling over fallacies. Here I examine a bit more how to logic check the structure of your arguments, which means checking how the parts of the argument fit together or don't. In logic, a fallacy is an invalid argument, one in which a flaw in the way it is constructed means that it's possible for all the premises to be true and yet the conclusion to be false. As such, you clearly want to avoid fallacious reasoning. It leads you astray, as well as your readers or listeners. People often use the term colloquially to include arguments they consider false because they disagree with one or other of the premises. The two ways of using the word should not be confused. Remember, not just any old type of mistake in reasoning counts as a logical fallacy. To be a fallacy, a type of reasoning must be potentially deceptive. In other words, look plausible. It must be likely to fool at least some of the people, some of the time. The statement, "It's a fallacy that paying people welfare benefits encourages laziness," is probably a critique of the following informal and politically incorrect argument. If people can get money without working, then they'll become lazy. Unemployment benefits are a form of getting money without having to work for it. Unemployment benefits encourage laziness. Is the argument valid? Skip to the Answers section at the end of this chapter for my comments. The rest of this section covers the idea of fallacies. To see why this is worth doing, check out the nearby sidebar, Focusing on Fallacies That Matter. Choosing your words carefully. Ambiguity is the enemy of a solid argument. One commonly spotted ambiguity is amphiboly, from the Greek verb to throw around. This fallacy results from the way a sentence is constructed, instead of from the ambiguity of words or phrases called equivocation. Amphiboly occurs when a bad argument trades upon grammatical ambiguity. Focusing on fallacies that matter. An incredible number of fallacies exist. People have written long books on them, starting with affirming the consequent, see Chapter 12, and finishing with unaccepted enthymemes and the undistributed middle. In between are fallacies with exotic names, such as poisoning the well, and Latin tags, such as post hoc ergo propter hoc. It's the same thing as affirming the consequent, not to forget quaternio terminorum, also known as the fallacy of equivocation. Such terms are imposing. They can make you feel like doing a course in logic, or more likely slinking away to the nearest bar with your tail between your legs. Don't be put off or intimidated. Only a few fallacies count, and the jargon used to categorize variants isn't worth learning or even understanding. Here's a suitably classical example. The Emperor Croesus is said to have consulted the oracle at Delphi to see whether the omens were good for his planned attack on Persia. The reply seemed to augur well. If Croesus goes to war, a great empire will be humbled. Thus encouraged, Croesus went to war, had a terrible time, and promptly lost. A mighty empire was indeed humbled, but it was his empire. Watching out for circular reasoning. You can all too easily produce a circular argument accidentally. This is a type of reasoning in which the conclusion is supported by the premises, which are themselves relying on the truth of the conclusion, thus creating a circle in reasoning which no useful information is shared. See Chapter 12 for more on this. Choosing the appropriate kind of reasoning. Don't start to see fallacies everywhere, because science, and real life generally, is all about inductive reasoning, drawing general conclusions from a limited amount of evidence. In real life, we use inductive reasoning all the time, even though it is by definition invalid, and it carries with it the risk of being proved wrong by future events. The trouble with doing this is that the next bit of evidence along would destroy the theory, as, for example, happened in 2008 to the entire Western banking system when it turned out that certain kinds of investments were not actually safe as long as they were all bundled together, as the dominant economic theory at the time predicted. The alternative approach, which promises conclusions that are rock solid and eternal, is called deductive reasoning. It is exemplified by logic and geometry, with their ability to demonstrate that, for example, 3 plus 4 equals 7, or that the angles of a triangle add up to 180 degrees, or that Socrates, being a man, is mortal. Claims like these tend to stay true. The trouble with this kind of reasoning is that in practice it tells you nothing you did not already think. It can't. That's why it's valid. Thanks, Aristotle. Remember, central to the distinction between inductive and deductive reasoning is that you can't get any new information out of deductive arguments. All that you can do is rearrange them. So when people accuse someone of producing an invalid argument, they usually mean something different, that someone is misstating a deductive argument. Spotting a fallacy. Suppose that you're having an argument with someone about whether starfish have fins. You know that starfish are beautiful marine animals that can be a variety of colors, shapes, and sizes, and have 5 arms, which make them resemble a star. But for the sake of this argument, you don't know whether they have fins or not. Can logic help you to settle the question? Major premise: all fish have fins. Minor premise: starfish are fish. Conclusion: starfish have fins. Professor, we have our answer. Or do we? Does this prove that starfish have fins? Check out the answers at the end of the chapter for a full discussion of this surprisingly important riddle. Putting steel in your arguments. In this section, I give some general tips on how to make your arguments more effective. Logic always has a rather frightening aspect. Perhaps you think that things in it are black and white, and that you'll look ridiculous if you make a mistake. That's often how teachers present it in philosophy classes, too. But critical thinking is concerned with real life, and logic is a valuable tool and a friend. Tip: when you're trying to assess the truth of someone else's argument, or indeed trying to construct one yourself, think of logic as a guide rope that helps you to navigate the treacherous paths through the mountains of political and scientific controversy. So crampons and grappling hooks at the ready. Taking a clear line. The first thing to consider when constructing an argument is whether you're contradicting yourself. Of course, any areas of social or scientific debate often include opposing arguments and conflicting evidence, and good writers are aware of this fact and able to include the controversy in their accounts. However, for readers, conflicting messages and inconsistencies are confusing. Tip: here are some tips on how you square this circle in your own writing. Make clear early on the general line you're going to take. Use signal words to flag what follows is an alternative point of view, contrary to the main message. For example, on the other hand, or alternatively. Explain how any contradictory perspectives and views that your research may have revealed can be resolved, perhaps by introducing a third perspective. Or at the very least, make clear to the reader the presence of an unresolved contradiction and that it's not just the reader who can't solve it. Choosing your words carefully. Many arguments are really just confusions about terminology. In fact, Socrates insisted that all human disagreements come down to this problem, but then he was executed by his fellow citizens after a vote, which implies he misjudged their characters. He was somewhat naive about the way different economic interests can lead people to have a reason to see things differently. Tip: you need to word your arguments precisely if they're to have any chance of being logical. Imprecise wording is a recipe for inconsistency and ambiguity, errors that bring an argument tumbling down later. See the exercise in the earlier section, Spotting a Fallacy, for how even everyday words can mislead. A sound, logical argument depends on terms having one fixed and precise meaning. But in ordinary language, as opposed to artificial languages such as symbolic logic or mathematics, no terms have a fixed meaning. They're all, to varying degrees, a little bit nuanced, a little bit context-dependent, and a little bit ambiguous, and usage may vary over time. Here's an easy question. Do parallel lines ever meet? Despite the adage, you bet they do when they're drawn on the surface of a sphere. So even math and logic are context-dependent, and logic can't get going until the precise meaning of the terms has been agreed. Remember, claims made using ordinary language depend on a degree of subjectivity and on, at the very least, a consensus about meanings and usage. Employing consistency and method. Remember, in a good, logical argument, the points made support the eventual conclusion. Another pitfall you want to avoid here is providing reasons that don't support the conclusion, perhaps because they're basically irrelevant or because they imply the reverse of the desired conclusion. This happens easily if you don't really know at the outset why you believe something is true, but are cobbling together reasons and evidence to support your opinion anyway. Tip: getting the reasons in the right place is important. Often people link reasons to each other that don't directly support the overall conclusion, but instead lead to an intermediate conclusion. A logical structure requires a line of reasoning in which first things come first, and related arguments are dealt with together. See Figure 13-1, which can be found in the print and e-book versions of this book. Answers to Chapter 13's exercises. Here are my answers to the two exercises. The "Does welfare encourage slacking?" argument. I say that this argument is valid, but I'm not a fascist, and you don't have to accept that the premises are true. Let me explain. Here, the argument hinges on if people can get money without working, then they will become lazy, which looks plausible, when understood as sometimes if people can get money without working, then they will become lazy. But it seems less so when understood as in all cases, and even less so when the amount of money is included. Plenty of scope for disagreement exists about the assumptions in this argument. For example, suppose that the first premise is expanded to say, invariably, if people can get just enough money from the government to survive without having to work for it, then they will all become lazy. Looks less plausible, doesn't it? But it's not a change to the logic, only to the content. The starfish argument. The argument as it is presented proves nothing because the word fish is being used in two different ways. In a strict scientific sense in the first premise, and in a looser everyday sense in the second premise. The sneaky thing here is that although starfish live underwater, they aren't actually fish in the scientific sense. Whereas fish propel themselves with their tails, starfish have tiny feet to help them move along. The fallacy is given the fancy name quaternio terminorum. In plain English, it's the fallacy of 4 terms. The logic depends on there being just 3 terms, with what logicians call the middle term being the vital link between the others. It's called the middle term because of its link role, rather than because it appears in the middle of the sentence. When you have 4 terms, you have no link, and the whole argument becomes random assertions, and the conclusion is unreliable. For the record, in this case, it's not just unreliable, but flat wrong. Here's a valid argument to remind you of how the middle term, in bold, acts as the vital link. Major premise: all fish have fins. Minor premise: salmon are fish. Conclusion: salmon have fins. In plain English, the argument is that salmon have fins because they're a kind of fish and all fish have fins. So, logic did sort out the question of whether salmon have fins, but maybe we weren't wondering anyway.